Hello. Hello.
Hi.
I can't hear anything. I can't hear anything. Can you hear?
Good afternoon.
Okay,
Good
sharp.
afternoon.
No.
Okay. Okay.
No.
Can you hear?
Hello, everyone. Good afternoon.
Afternoon, sir.
How are you
Sir.
doing?
Fine, sir.
Good, good, good. All right, guys, we're just going to give about 2 to 3 more minutes. Some of your friends are still joining. Okay.
Yes, sir.
Afternoon, everyone.
Afternoon, miss.
Afternoon.
Afternoon, miss.
Afternoon, miss.
Afternoon, ma'am.
Afternoon, miss.
Okay, I think everybody is here now. Most of you are here. So for now, what's going to happen, let's quickly pray before we start. Okay. Right, let's bow our heads and pray. Well, Heavenly Father, we thank you once again for this evening, afternoon, Father God, that we can connect with one another. Father God, thank you that we have the privilege to have you amongst our fellowship, Father God. Father, we just pray that the Holy Spirit can minister here as we are sharing information and knowledge of Father God. Help us, Father God, to have a sound mind for tomorrow's aspect, oh Lord. Help us also, Father God, to remember what we are studying, oh Father God, that we are all able to recollect, Father God, whatever we have studied, oh Father God. Therefore, we pray, Father, that you be with us as teachers, that you, Father God, the
Amen, my Lord.
Amen.
Amen.
Amen. Okay, sorry guys, sorry. Hold on. There is a mute. A meal.
Can you all hear me?
Yes, sir.
Okay, sorry.
Yes, sir.
Yes, sir.
Yeah, sorry,
sir.
guys. There was a bit of a problem when we would pray. Some of the things were muted and we couldn't hear nicely. But anyhow, listen, I want you all just to make sure that you have your real names on so that we know who we are talking to, especially if you're engaging in the class. So yes, thank you so much. Everybody has their name there, so it's fine. All the names that we can relate to, so that's perfect. So I don't want to see the device name, please. If you put maybe Frank's iPhone, that's
Genuine
okay.
iPhone.
Frank's
That's
Android
okay.
device, that is still okay. But not just the device. I would want more than that. Okay, so thank you so much. So guys, we haven't got any enough time just to go through all the questions that you have put there. We were still setting up the technical part of it, but we can go through it as we are going through the questions. But main thing here is that on part 1, 2, and 3, we have summarized all of this for you. So that should be fine for everyone. And I am so glad and I am really proud of some of you that could really ask specific questions. That shows that you have worked through it. So before I give it over to Ms. Mugunda, I just want to just let you know that if you look at the questions that are the most in all of that will be the geometry papers, right? Especially when we are doing the graphs. There will be graphs tomorrow, guys, trust me. And also the part 2 on algebra on statistics and probabilities. You will have something on statistics, either to draw a histogram or to put an accumulator frequency, but it will be there. So please make sure that you draw those graphs. Okay, so where do you want us to start? Just in the text box, just put part 1, 2, 3. That's all we want to see in the text box. Just part 1, 2, and 3. Okay. All right, in the chat box. Okay. Part 3, part 3, part 3. Okay, wow.
Okay.
All right.
Yeah, yeah, part 3, sir.
Listen,
And a
Danny
bit
boy.
of 2.
Danny
Okay,
boy,
sir.
follow instructions, please. Né? Just put it in the chat box. Wow, part 3 is really overwhelming, eh? Okay, now in part 3, we've got 1, 2, 3, 4, 5, 6 topics. Okay, let's be specific now. From those 6 topics, the first is mensuration, geometry, functions and graphs, coordinate geometry, vectors and transformations, and then finally bearings and tree. Now, part 3 is the only thing that I've got now in the in the chat box. Now, let's be specific. Okay, part 3 is the point where we will start. But now let's be specific as to which part. Are we talking about, you can either put it there as topic 4, topic 5, topic 7, topic 8, topic 9 or 11. Don't type it out as topic. You can just put 4, 5, 7, 8, 9 or 11 so that we can just see which part is the one that needs attention. Okay, so it's clearly part 3. Thank you very much. Okay, rather put the topics in. Okay. All right, let's see. Now we've got quite a mixture here. All right, let's see. Ms. Mugunda will help me here on the side to see which one surfaced the most. 7, 7, 7, 7, 7, 7, 7 seems to be the one. Okay. 7 and 8, 7 and 8, 7 and 8, 7 and 8, 7 and 8. Okay, good. Okay, let's see. Let's try to do a tally. Okay, put it as 4. Okay. Okay, let's just look into it. Let's check what Ms. Mugunda can do here. 7 is there, 9 is there, 11 is there, 9 again, 5, and then 5 again, and then 11, 8, but 7, 7, 7, and then 11 and 8, 7, 9, 7, 8, 7. Then we've got 5 and 11. There's 4, and then there's 7, 8, and then there's 5, 7, 11, and then we also have. Okay, let me just Okay, then we also have 7, 8 again. 7 is there. 5, 7, 8, 9, 11, 11, 4, 8, 8, 7, 4, 7, 7, 11, 11. All right. Okay, let's see. These are all the ones that we have. Okay. All right. So where do we have the most? Topic 7. Okay. Topic 7 and 8. Okay. Okay. So guys, I think the biggest thing, or the thing where we can start, this is my proposal, nah, is to start with plotting the graphs. Okay, to have an idea as to how we need to plot the graphs. Okay, so let me do the following, guys. Let me do the following. Okay, I'm going to quickly share something here. It just came up now. As I was seeing the need behind this. Okay, so let me just put that away. Just give me a second. Okay. They do. Okay, listen, guys. Miss also wants you to put the specific questions you have also in the chat box. On part 3. So the specific ones you have, also put those ones in the chat box. If you talk to them. Okay, just give us a
Okay,
second. We
okay.
just
Can you put the specific questions in the group? I mean, on the chat box. You must maybe say topic 4, question 5, topic 5, question 6, or something. 6A, 6B, like that. Yeah.
okay, guys. We just trying to put everything, your request here, and it's also giving the others chance to join.
Otto, can you also just put your questions here, even if you put it on the group? Net topic 9A, or it is just question A of topic 9? Or you want a question on vectors in 2 dimensions? Net? Disconnected. Ned,
Yes.
Which one, ma'am?
which specific question do you have on vectors into dimension?
On which topic, ma'am?
Vectors into
Okay, so-
dimension. I see you indicated you want to help
miss.
with 9N. Which specific question did you go through that you have a problem with?
Yes,
Let me just go to the question right now.
Yeah. What's going on?
Also, question 2 of number what? I mean, question 2 of topic what?
Topic 7, miss.
Miss,
Topic
my
seven.
thing is,
Oh, okay. Okay.
I don't know, there's something wrong with my screen.
Yeah, I get it. You.
No, mine's also not showing like.
I
No,
just
no,
showed me.
I stopped sharing, guys.
Oh,
Okay.
I'm just quickly putting up something that I was trying to get ready. But
Coordinate geometry, I think. Let me type.
I hope you all try to work out the question.
yes, ma'am.
Okay.
Yes, miss. Yeah, it's back now. Coordinate.
All right, guys. Okay.
That's my old rule.
All right, guys. Can you all hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, Jambos.
Okay, Miss is just quickly highlighting the stuff there. Okay, good stuff. Now I was just moving everything to the laptop I'm using. So guys, thank you so much for the input. So Miss is having the specific questions and she can see everything on that one as well. So I think there was some Messi saying that we should start with topic 4.
Send. Yeah, so take it off. And yeah. Okay.
Okay, guys, somebody, I don't know whether there was a recording, but there's a bit of a delay there. Okay. So everyone, we will then start. So guys, listen, The common problem we are having is from the third one. So let me just get that. Okay, where is my part 3? Okay. Everyone, I hope you can see the screen. Just give me thumbs up if the screen is showing on your side.
Yes, sir.
Thank you. Okay. All right. Then let's start. We will start with topic 4, question 2. Miss says question 2. Okay. All right. So here we are having mensuration. Huh? Sorry, guys, I'm hearing myself here. So let me just
Yeah, say what?
try to
It's tripping.
arrange something here.
So we're not gonna do question 1.
I can't hear anything that Sir is saying. Because Sir is having a network problem.
I don't think they're
Okay.
saying anything right now.
Sir
Yes,
isn't talking.
yes. All right,
Sir
guys,
isn't
listen.
talking at the moment,
Hello.
Danny.
Hello,
Jumbo.
hello, guys.
Mm.
Hello, everyone. Hello, can you hear me now?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay,
Wow.
okay, guys. Now that's good. That's good. Listen, guys. We're going to start. I think there's a delay on Danny's side.
Yes, sir. There is a delay, sir. I don't know, but it's not show. It's just standing still.
Go Yeshla.
Can you please ask that question?
Hello.
Hello, Mia.
Okay, I everyone, can you
Hey,
still hear
Danny.
me?
Yes, sir.
Okay, guys, there was a bit of a problem because we've got 2 laptops next to each other, so there is a frequency, overlapping of something. But anyhow, I think it's sorted now, so you all should be hearing me in real time. Okay, so guys, in this regard, I would just like us to start with this question. It's on mensuration. So we are told here, let's just get the pen out and then we can start. Okay. So guys, I would also like you to be quiet as possible. If you've got a question, you can always raise your hand. You ask your question so that we make the best out of the time we have together. All right, everyone. So here we've got a water funnel that has a radius of 8 centimeters. So they show us that this is the radius of 8 centimeters. It has a height of 24 centimeters. So from the top here up till the bottom part of that here, we can see that it is a total of 24 centimeters, okay? Now they want us to calculate the capacity. A capacity is almost the same as, in this case, volume. Are we together? How much of liquid or whatever you put into that funnel can this funnel take? So in other words, they are asking us to find the volume of this funnel, okay? So now in this case, we'll always be given the volume and surface area formulas for the cone, for a pyramid, as well as the sphere. So in this case, they give us the volume of a cone, which has a radius of r and a height of h. So basically, this is just general.
Yes, sir.
Are you following? Okay.
Yes, sir.
So what you need to do now is you need to identify where is my height, where is my radius. Now, in this case, this will be the height. That's what we were told. Okay. So we've got the
Yes,
height
sir.
over. And then furthermore, we have the radius over here. So the height is now, basically your h is now 24 and your r will be equal to 8. So that's what you need to come and do into this formula. So in this formula, we'll now say 1/3 multiplied by pi, and then the radius has to be squared, and then we substitute the h. So your radius here will be 8, and your height here will be 24. So we just plug it in like this on the calculator, and then we will then get the units. I mean, the units are already given here, centimeter cube. So I need somebody to help us with the calculator there. Just punch it in, and then we should get
1608. So 1608.5 centimeter cubed.
0.5 centimeter cube. All right, guys. So if the answer is not exact, they always say we must round it off to 3 significant figures. Are we together? All right. So this is definitely more than 3 significant figures. So that's fine. We can keep it like that. All right. And then they say calculate the total surface area of the funnel. At this point, I want you also just to notice something here. They show you something over here. Let's just get a highlighter here, that this is the middle part of the funnel. Okay, so sometimes it will come to the point where you need to work with ratios as well. Yeah? But at this point in time, they are still asking us to calculate the total surface area. So which means all of this, basically we need to get all of the funnel. All right. So again, the formula is given over here. So the total surface area of a cone should be the radius as well as the slanted height, which is represented by L. Now I want you to see, let me draw a cone upright, okay? Okay, sorry guys, this is what a cone looks like. So this at the base. So what I want you to understand is this height that is perpendicular to the base. Let's add the radius as well, okay? This height here, that's your H, which is perpendicular to the base. But then you also have, yes, Brandon, your hand is up.
Yes, sorry, I just want to know if we could maybe after this one do paper or question 1, because I see everyone else is also asking if we could do question 1.
Okay, okay, that's good. It's still under the same thing, all right? And then this height here on the side, all right, Brendan? This is known as your slanted. Are you following, guys? All right, so if you see slanted, it means it's not upright. It's kind of like lying down something like this or to that side, as long as it is not upright, meaning that there's no 90 degree there. That's what it means to be slanted. Now, in this case, guys, we are not given this, but we can work it out. Does that make sense? Okay. So how do we work it out? We need to look at the shape that we're given, and then we can work it out by applying Pythagoras. Okay. So let's see what we can do. All right. So let's just clear. Let me change my eraser to just erase the object. I think that's faster if I just touch the object. So look here, guys. So what we need to understand here is look at the ruler. So if I take this ruler here and then I put it down here, all right, something like this, and I draw the line that I have over here from the top here to the bottom part here. That is the same as the 24 centimeter I have over here, right? Okay. And then we've got the radius over here. So if I then have my radius here as 8 centimeters, then the slanted height that we have here on the side, this part here, maybe we can use a different color for that. This is the slanted height. That's what we need to calculate. Maybe using, this highlight is just too much. Let me put it. Okay, so yes, perfect. So that slanted height, how will you get it? By applying Pythagoras, isn't it? So since I have this triangle, then we only focus on the triangle. So we know that this side over this one over here, let's just get a different color. This will be 24. So which means if I can take that triangle out, it looks something like this. Are you following, guys? Okay. All right. Sorry. All right.
Yes, sir.
So this 8 centimeters and this is 24 centimeters. This is the unknown. Now the radius is always perpendicular. Are you following? So this is 90 degrees. So that means we can apply Pythagoras. Since we're looking for the hypotenuse and we've got one more short side, we'll say the sum of these two areas will give me the area on this side, square root of that. So basically, the side we are looking for your L will be 24 square plus then the 8 square and square root everything. The answer that you get there will be the slanted height. Okay, somebody help us with that, please.
25.3 centimeters.
25.3 centimeters. Mia, tell me, is that the exact answer, or did you round it off to one decimal
No,
place?
sir, it was rounded off to one decimal
Okay,
place.
try to give me at least give me the full calculated display. So it's 25.2 something.
Okay,
something,
hold
was
on,
it?
sir.
0.298222128.
Okay, okay. So at least
Yeah.
take it up to here. At least take it up to here, so we avoid premature rounding, yeah? Especially if we
Okay, sir.
substitute it. So basically, this is your L. So what are you going to do? You're going to take this formula that you have over here, and then you're going to substitute what is necessary to get your total surface area, because now you've got the slanted height. So what are we going to do now? We're going to say that your surface area of the cone will be equal to the pi. Use the pi from the calculator. So the radius is 8 and the slanted height will be 25.29822. For me, at this stage, you can even plug in the complete, what is this, the whole calculated display. So if you do that, what do you get, guys?
635.813.
600 and what is that?
638.8.
0.8. Okay, so that is fine. So that will now be the total surface area. So look at that. The
35,
unit
sir.
35, sir.
No, sir.
35.
Is it
635.
Okay, okay, let's fix that. Okay, perfect, perfect. So once you are done with that, that means this is your surface area. If they didn't give us units, then we'll just put it as unit square if you're looking for the area. Are you following? Are we together, guys? Okay.
Yes, sir.
If you're looking for volume, you put unit cube. If it's just for a length, which is in one dimensional, you'll just put it as unit. Okay, now let's go further. Now, in this case, they are saying that after a heavy rain, the funnel is full to the height of 6 centimeters. Now you need to understand, look at this. So it's up to 6 centimeters. So you remember the funnel was like this, right? So when it rains, the water level comes up to here. So this is where the water is. And then if you come and measure here, you will see that this height here will then be 6 centimeters. Are you following? Okay. Now they say, now if the funnel is empty, or if the funnel was empty before the shower, before the rain, calculate the volume of water in the funnel. Now guys, they have to tell you that this was empty, because if there is something, it will be an assumption. Are we together? So this part just clarifies. So this is just for clarity, né? So it just clarifies what we have to do. Now remember, the volume was given as your third times it by pi. Who can remember that? And what else do we have?
Radius.
Radius squared height.
Right?
Squared.
Squared
height. Yeah.
So can you see what's happening here? Any volume will be the area of the base, right? This is basically the area of the base multiplied by the perpendicular height. Are you following? So now your height is changing to 6 now, instead of using the whole 24. Remember, from here to here, the empty one is 24, but the water is only up to 6. So what are you going to do? You plug in now 1/3 multiplied by the pi, and then your radius. What is your radius here, guys? What will be the radius here?
8. It should be 8, and the height will be 6 because
exactly because you are considering the entire funnel. Okay, so your radius will be 8, and then that you need to square, and then we will then get what? This will now be height will be 6. So Mia, what do you get if you plug this in?
401.92.
Okay, so let's put it in. Let me just What do you get if you plug? Why am I okay? Let's just multiply mine with the. I got a calculator here. So one, they can give you 128 pi. You can also leave your answer like that. Or the other one, if you then put it, will be 402.12. I think the 2 decimal places are fine. But if you had to put it to 3 significant figures, 402 would be the final answer. Does that make sense, guys?
Yes.
Are we
Yes,
together?
sir.
Okay,
So
perfect.
mine doesn't say 402, sir.
Yeah, no, that's still fine. Okay. Yes.
Oh, it's still fine if
Um,
it doesn't say 402. Okay. It
When
shows
we did C in
399.
class,
Pardon?
because when we did C in class, when we had
Mhm.
because we had a previous paper like this, we first had to find out the new radius because it wasn't completely 8, and then we had to find out the new radius for like the middle.
I think then we need to double check that. We need to double check what you're saying. Hold on,
And
let me just accept
But
your
sir,
fact.
it's true because it gets smaller down the.
Yeah, it can't be 8.
Exactly.
and
Okay,
so
thank
then we
you.
So
first had
look,
to
it
find
can't
out
be
the
8
new
because
radius.
yeah, and then you just take the difference between the 24. Like, how many times does the 6 go into the 24? Then it's 3 times. So then you divide the 8 by 3 and you get 2. So the radius is 2, not 8.
Okay,
Not
perfect,
8.
perfect.
And then for the
Yeah.
final volume, you get 25.13.
Okay, okay. Let us look at that. But before I look at that, Delanas, your hand was also up.
So I wanted to ask, can we leave the answer with pi in the exam?
Yeah, it's fine. It's even more exact. The answer with pi is even more exact.
Yeah.
But they also accept that as well. Both are acceptable.
Okay, thank you, sir.
Okay. All right, guys. So let us then apply. Let us apply our mind to this. All right. So let's follow this. So guys,
So, okay, sir.
Yes, yes.
So can I quickly explain like what I mean by the whole thing? Like what me and Mia.
Yes, I get the ratio. So let you explain,
Okay.
then I write here as you're explaining. Okay.
Okay, sir. So since it's x is now 6, and then the total length was 24. So you divide 24 by 6, you get 3. So then you have to divide 8 by 3, and then you get the radius of 2.
So
Not 2, not 2. It's 4. It's 4.
Okay,
Yeah,
let's
4.
stop
Sorry,
there.
not 3.
Let's stop there. Can I do this big, and then I put small here now? So what I mean here is the big funnel, okay, and then we have the small funnel. Okay, I think I can take this away. So it's one thing. Now what I'm trying to say here is we're going to look at the ratios. Are we together? Because this is a uniform funnel. All right. So if we now compare, okay, listen, guys, we're only looking at the height now. Okay, so the heights that are given. So if we look at the height, hey, guys, let's listen. If we look at the height, the big height was 24 against now the 8 for the small one. Are we following? Okay. And then
it's against 6.
Is it against the height? Oh,
Yeah.
yes, sorry. That's the radius. Okay, thank you. Against 6. And then we use this ratio to find the radius. Now remember, this radius here is unknown. All right. So it's good that we picked up. I asked which radius will we use. All right. So now in this case, what's going to happen here is for the 24, I have the radius of 8. So if this is a uniform funnel, then I can use this ratio to find my x. Are we together? Or rather, should we make it r, since we have x here, so it avoids confusion. So I can put this as r, okay? Maybe r small, which means radius for the small funnel. All right, so I can use the ratio, and then I'll find out what will this be. Does that make sense, guys?
Yes, sir.
All right, so I'll have 24r, and then what do we get if we say 8 times it by 6? What does that give you? 48, and this is 24r. So divide this by 24, divide by 24, they cancel. Your r will then be equal to 2. So your radius is 2. Perfect. So I'm happy that you could get that. what does
you
this
could
mean?
also just do 6 to 24 and then divide the
Mhm.
24 by 8 to get 3.
Okay, so
And then you say 6 divided by 3 is 2. Because then
So
like
what
Or
Mia
you
is
can
saying
say
is
6
how
to 24.
how did I get from 24 to 8? So she said if I divide
Yeah.
that
Yes,
by 3. Now I do the
Yeah.
same thing here. How do I get from 6? I do the same thing, divide by 3. That will also give me 2. That's also another way of
Yeah.
doing it. Perfect. All right.
Yes,
So
sir.
Yeah.
once I have that, then I use that for my volume. So it'd be 1/3 multiplied by pi. My radius is 2 squared, and my height will just be 6. So if you plug this in your calculator, what do you get?
8 pi.
25.132.
So you get 8 pi,
74123.
8 pi or
25.13 if you round to 2 decimal places.
25.13. Okay. So that is what
Yeah.
we get. So either one of us. So now
You
we
get
know that,
5.
that is the volume of the water at height of 6. Okay, so that part is fine. Can we move over to the next question?
Yes, sir.
So now they are saying now if the height of the water is x, so what do we have now? So the height of the water here is x. Just hold on a little bit. Just hold on a little bit. My son is here. Angelo?
Yeah. Let's move on to the next question. Hello, guys. Danny.
Hey, Danny.
So we can't hear you.
I'm Danny.
Okay, sorry guys, sorry. I quickly had to attend to my son. I wanted to hear what he wanted. Yeah, yes. Okay, guys. So yes, now let's go further. So here they ask us to do what? The height of the water is x, and then they say the radius of the circular area of the water in terms of x. So guys, I remember we were asked this question, either Bhuvi or Helen was asking this question. So my wife and I were looking at it now. So it's a bit of a tricky question. Here they're asking in terms of x, which means that this should be an equation that you have in terms of x. So which means x should be the subject of the formula. So you should say that that x should be equal to that. Does that make sense? Okay, at the end of the day. But now what they want us now to do is they are saying the following. Find the radius. Just hold on a little bit. Okay, just a second here. I just quickly need to help Miss with something here. Just a second. Okay, sorry guys, the other laptop, I have to just put something there. All right, so let me put my pen. All right, so now it says, let's go on. So we said that it must be in terms of x, which means x must feature in that equation when we come up with the equation. Are you following? Now it says find the radius of the circular surface area in terms of x. Now look at this, guys. If you look at that, what is this? That funnel, then it looks something like this. Let's try to draw it here so that we have everything together with the question. All right, now in this case, what we have over here is this level. Sorry, I hope I can get that in. It doesn't want to work the way I want it. Okay, let's try to put the pens up there. All right, so maybe an oval like that. All right, that looks much better. Now look at this, guys. This, we are told that from the top to the bottom, this whole thing here will now be what? That will be 24. And then the radius, this was 8. All right. And then they tell us that the height over here was what? 6. Sorry. Here we have it only in terms of x. Let's keep it like that. Okay. So here it's x. So they are saying find the possible radius in terms of it. So what is it that they want us to find? They want us to find the radius over here. Does that make sense? because the radius that we have here is dependent on the x here. Are you following, guys? Are we
Yes,
all
sir.
together? All right. So
Yes,
now
sir.
what we do, we can still use the ratio that we had as the 24 to the 8. Does it make sense? Okay. And then if we then plug in from the 24 and the 8, those are the given ones that we have in terms of this and that. Are you following? Is that still fine? Can I put them
Yes,
like
Yes,
this?
sir.
Are you
Yes,
sure?
sir.
Yes.
Are you
Yes,
sure that,
sir.
that we can put them like that?
No,
Why-
sir.
why-
It, the
why am I
8 has to
relating
go.
these two? What do I need to
No.
fix here?
The 8 has to go below the 24.
Yes.
And so,
Okay.
yeah,
Yeah.
the x should be there where the 8 is.
Exactly.
Yeah.
Exactly. Because you are
Yeah.
saying the 24 with the height. So the 24 with the height was x, right? Are you following?
Mhm.
Yes, sir.
Okay. And then this is now in terms of height. So you need to relate height to height. So you are using basically similarities here. Are you following, guys? Okay.
Yes, sir.
So 24 to x. Now the next relation would now be what? So I
The
plug in
8 to the other
24 was
radius.
the 8. Yes. And can I put this as r because that's my radius? Are you following?
Yes, sir.
Okay. So then what do I do from this point? Now, the first thing is we just need to make sure that we
Okay.
get this relationship right. So this part now is in terms of the radius. Does that make sense? Okay. Now what
Yes,
else
sir.
do I have to do here now?
Union.
What else do I have to do here now? Can we go further now? I want you to apply your mind. So let me just
So
quickly
now you see you divide the 24, or you see how many times, yeah, you divide 24 by 8, so then you see what it takes for, wait, yeah, now I'm
I
confusing
can't
myself.
hear
Yeah,
you.
so you divide 24 by 8 and then you see what the answer is, then you divide by x by that as well.
We can't hear. It's mute. Brandon.
What is it?
Brandon,
I don't know.
Yeah, I don't know. It's mute. It's on mute, bro. It's on mute.
These are near my.
Down mute. All the fast cars outside.
Hey, Spurt.
All the fast cars outside.
All my brothers killed.
Brandon, sorry, I was looking. Nancy is trying to come in twice. Danny, I need you to focus. Okay, from this point, I want us to be on the same page. Let me just quickly rewrite this, okay? So this is wrong where we have 28 and 24. So what did we say? Let's just get a pen out here. So we said that here we must have 24 together with the x.
X.
All right, and then we said 8 together with the radius as to what we're looking for. Okay.
Yes, sir.
So from this point, all right. So what were you saying?
Okay,
Brandon?
so you divide 24 by 8, then you see
Mhm.
what the answer is. So it's going to be 3, and then you divide x by 3 as well to get r.
Okay, but why do you divide both? Why do you divide both by 3?
Because that's the because they're in relationship to each other. So they're 24 and x are like, I don't know how to explain it. They're in, I don't know, sir. Because that's how the ratios work, sir.
Isn't it because like you have to do on both sides the same thing?
Yeah, maybe, I don't know. I just know that's how you're supposed to do it.
No, Brandon, I don't want that. Okay, anyone input from the other side? There's a step we are missing.
Don't have to cross multiply.
Why do we cross multiply? Guys, why do we cross multiply? Guys,
Said
this is
Jumbo's
correct.
bad.
This is correct. This is
We cross
correct.
multiply for the equal sign, sir.
Yes. Now look here. Look here. At this point, because you are using similarity and both the height that we have here as well as the radius is in one dimension. So you don't need to square, you don't need to cube anything. They are both in one dimension. Are you together? So I agree with the cross multiplication. If it was that maybe you were comparing a length with the area or length with the volume, then you had to square for the area, you had to cube. Are you following, guys? So this you do it straight away. So we'll have 24 r is equal to 8x. And then you make the r the subject of the formula. So you'll divide by 24, you'll divide by 24. They cancel out. So the r will now be equal to, if you simplify, 8 goes into itself once and 3 times. Yeah. So it's basically a third times an x. So your radius here will be 1/3 multiplied by x, which can also be written as x over 3. So this is your final answer. I hope it makes sense, guys.
Sir,
Yes, sir.
I can't see the number down. Is that 24 down there, sir? It's not
Okay,
34.
Look, let me just write it here, Danny. So we were comparing the height here, 24, all right, against the x, and then we're comparing the radius, 8, against the r.
Yes, sir.
Are you following?
Yes.
So
Yes,
what
sir.
you need to understand is the first set here are the ones that we are given. These are the ones that we do not have. You see, this is the r that we put over here. So from this point, we did the cross multiplication. So 24 times r would be 24r. And then 8 times x would be 8x. And then since you are
Yes,
looking for r, you make that the subject of the formula. So how are we going to get rid of, sorry, not this. This is the r up there. So we're going to divide both sides with 24. So this will cancel. So the r will now be 8x over 24. So 8 can go once and 3 times into 24. So basically you'll have 1 on top with the x, and then you'll have the 3. So that's why I'm saying you can write it as x over 3. That will be your r as your final answer. Guys, we need to speed up a little bit now. Okay, we need to speed up a little bit. Okay, so I think this question is fine. Are we all fine with it? Can I move on?
Yes, sir.
Yes, sir.
Okay, okay. So
Yes,
if I go further, then the next one, what do you now need to do?
Now we
What do we
need
now need to
to
do?
give a formula with x and pi in it.
Exactly. Now show that when x is 6, the formula gives you the same answer. Look here.
Yes, so
when
we
x
skip.
is 6.
So
did we
we
skip
so
a
we skipped the
question?
yes, so the
Oh,
previous
sorry,
one.
sorry. Oh, yes.
Sir,
this is the question.
sir, skip number 2.
Yes, sorry, guys. I was just having this under my view. All right, so can I then do this? Can I just get rid of all of this so that we can have
Yes,
space
sir.
for that question? Right, it's fine. All right, so now that we have the previous answer, I'm not sure whether they are related. Let me just check. So in this case, I will now have my final answer here. We said will be x over 3. That's
3.
why we
R
have
is
it in terms of x. You could have just put it like this. Even if you put r is equal to, that's still okay. Yeah, since they are just looking for the answer. Now find the formula for the volume of water in terms of pi and x in its simplest form. So what is the volume of the water? What will we do here in Rome 2 now? Volume of the water. Remember, what type of cone do we have? I mean, what kind of shape? It's a cone, right?
Yes, sir.
So what
Yes,
will
sir.
what will the formula be? That formula is given, isn't it?
1/3
Yes, so 1 over
pi
3 pi radius squared height.
Radius
Pi
squared.
radius squared times it by height.
Yes, sir.
Yes, sir.
Okay, so now what do we need to do now? What is different here, guys? This is equal to, so I put my that, and this is still fine. And then what do I do now?
R you put x over 3.
The
X
r
over
is
3.
x over 3.
X over 3, because
X
that's your
over
R
3.
now, isn't it?
Yes.
Yes.
And then
Yes,
you put
sir.
your height. Okay, so then what does this mean now? They say you need to put it in its simplest form. What is the simplest form for this? Basically, what you are doing is you are multiplying this with that, you're multiplying this with that, you're multiplying this with that. One way of doing this is you can take it then as fractions. So you've got 1/3 multiplied by pi multiplied by 3, x over 3 multiplied by h. Now those ones here I can put over 1, right? So what do we have? If I have it like this, I can multiply the numerator with the numerators. So I can say 1 times x, 1 times pi times x times h.
The radius is squared.
Perfect. Thank you for that. So this has to be squared. So we'll have square and this will be squared. So in other words, what do we have here? Pi, we'll then multiply by this, and we multiply this with x squared. We can even put it as 9, and then we multiply it by h over 1. Okay, so on top, if I multiply 1 times x times this times that, will give me pi x squared and h. And at the bottom, 3 times 1 times 9. 3 times 1 times 9, what do you get if you do that? 3 times 9 is what?
27.
27, sir.
27.
Okay, so now in this case, you can leave it like this. This is your simplest form. Nothing else can simplify from here, isn't it?
Yes, sir.
All right, now they say show that when x is 6, the formula gives you the same answer that we have in question C. So what do we now need to do? Pi x squared h over 27. Now in this space, in this place of x, we'll now replace that with 6. So we'll say pi, and then that is squared. Okay, and then this is your h. What is your h, guys? Remember your h was given as what? They gave it to you as 6.
24, sir.
24.
24.
6, sir. 6.
No.
6.
Yes, your h is here as your x here, nah? It can be confusing.
Okay.
So your h is your 6. Yes. All right. Is that your h? And then 24. Double check, guys. Are we having the right thing? So what do we put here at the x squared?
6 also, sir.
Okay. Does that give you
Yes.
the same answer as the one we had previously?
Yes, sir, it does.
It gives you the same answer.
Yes, sir.
Did anyone else confirm?
I'm confirming.
I'm confirming.
What was the previous answer? Let's just put that answer here so that we are on the same page. Pardon?
By
28, sir.
28 pi.
Yeah, 28.
No, it was 8 pi
8 pi.
over 25.13.
The
Yes.
previous answer.
Yes, sir, but it's not
In C.
24 underneath the formula, it's 27.
It's
It's
27.
27, sir. Not
Oh,
24.
sorry, sorry, I made a
27, that's
mistake
what-
here. Yeah, it should be 27.
Yeah,
Yeah,
Yes, sir,
Yeah.
then it's right.
that's why I was
Then it works.
wondering why was it coming from 27 to 24.
Okay, so do you get the same answer?
Yes, sir.
I think the
Yes.
tricky part here, guys, is the 6 that they give you to substitute for the x. And then unfortunately, your height is also 6.
6.
And in the drawing itself, it says x is also 6. So it can be fortunate and unfortunate.
5.1.
Yeah? So that if you substitute it, then it's fine. All right. In the chat box, NG, you are saying that we're not supposed to get r in terms of x, which means the equation will be r is equal to. Oh, okay. Yes. No. We fixed that one there. Okay. No, that is fine. Now we are on the same
Yeah.
page there, NG. So yes, x should feature in the equation. R is equal to that. So that's fine. Okay. So is that the last part of this question?
Yes, sir.
So let's go back to question 1 then. All right, guys, let's quickly look at this. Now here, what we need to understand, now listen very carefully. Guys, I hope the other people that are not taking part in this are also listening. So guys, please give me a thumbs up, rather put up your hand if you're in class. Ms. Mugunda will just double check that everybody is in class. Those that don't put up the hand so that you're behind your device. But let's go through this question now, okay? So guys, I wanted us to I want us to engage that. So I will put up something if there's a little bit of a doubt that I want to get your opinion on it, and then you must say reason as to why it is like that. But due to time, I will then go a little bit faster on this question. So I see Danny Boy, put up your hand, Jada, Jamie. Okay.
So I can't put up my hand, but it's fine. I'm here.
Okay, good. No problem. Okay, Esteban, I don't see your hand. Engelbrecht, that should be Emmanuel, I think. Okay, good stuff. Thank you, guys. Most of you are here. You can lower your hand. So I'm gonna go a little bit fast here. Let's go through this. So here we are shown a diagram of a toy which is made up by two parts here now, the hemisphere and then the cone. So where is the hemisphere? Hemisphere is half of the sphere now. So this part that I'm drawing in red is the hemisphere.
Hemisphere.
Okay, if it was the full one, we would call it the sphere. So here it's half of that. And the one that I'm drawing with the blue is this part here, which is the cone.
The
And
cone
then
part.
the part that I draw now with the green here, that's the part that's shared between the cone and the hemisphere. So they are together. So whenever we are seeing these dotted lines, we can see that this is a three-dimensional shape, including the X and the Y and the Z axis. Now all three axes are shown here. So this is your Z axis, this is your Y axis. Now we go further. This cone has a radius of 3 centimeters. Now guys, at this point, let me just open it up. Since they share this, this is the point that they share. So if the radius is 3 centimeters, that means the radius for both the sphere, or rather the hemisphere, as well as the cone are all 3 centimeters. Are we together on that one? Just give me a thumbs up. Okay, good, right. Okay, then they say the slanted height. We have clarified what the slanted height is, and that's what they gave us over here. So this is the slanted height that I'm indicating with the green color. So that is the slanted height at 5 centimeters. Now you see what they have done here. They did not give us this one here, which is the height. But what do we have here? Just look at this triangle over here. I'm going to take it.
We
with
have a
highlighter.
90-degree triangle, so we can
Yes.
use
So we can
Pythagoras to find the height.
Perfect, the height. So basically, if I take this triangle out here, then it looks like this. So we've got the height, which is my h. We've got the radius, which is here. And then we've got the slanted height over here. Does that make sense? So this is what the triangle looks like. All right. So if we fill in the gaps, this will be 3 centimeters. The slanted will be 5. And since we know Pythagoras, this will be 4. Are we together? So how did I get to 4? Since this is my
5 squared
here,
minus 3 squared.
perfect.
And
5
then
squared.
square rooted.
Perfect. So this will be square root. So this will be 25 minus the 9 square root that.
Which gives you
25
16 square root is
that,
4.
4. Okay. So you know square root can give you plus minus 4, but we're working with height and distances here. So we only consider the positive one. Okay. So that part is fine. So that means our h is now 4. All right. So I think all of us are together. That's what they actually asked us to calculate here. So that would be 4 centimeters. You would put all of this here as you're working, and then you'll get your 4 centimeters. Now they want to know the next question, the height x centimeters of the toy. Okay, so
It's
now
7 centimeters.
So it's 7 because you add 4 plus 3 because the radius cuts through the
Because the radius
through the
is
whole
3 and the radius is
Yes.
the same throughout the circle. Or
perfect.
hemisphere.
Semicircle.
Okay,
Hemisphere.
great. I like that. Okay, now what you need to consider here is that this whole thing, that's the toy. Does that make sense? That is my toy. Now my toy, as I said, has the cone part here, which is the blue part. All right, and then they share this one here that we say, then that part over here. So they share that. We use that for your calculations. And then maybe the bottom part here, maybe we could use yellow. I hope we can still see the yellow. So this is what the bottom part looks like. So it's everything together. Now remember, what you calculated here was the height up to here. And that height that you had up to here was 4 centimeters. But since the radius here is 3, that means if I move anywhere on this circumference, which is basically my arc here, that means from here to here is 3, from here to here is 3, so is it from here to here 3. Therefore, 4 plus the 3, everything together will give me 7. I hope that is clear. It's the whole
Yes,
point.
sir.
Are you following? Okay. All right, that was okay. That was the other question. Okay, sorry. My wife was checking something in the text box. So basically, it is the 4 for the cone plus then the 3 from the hemisphere, and that will give me 7. Right. What is the volume of the toy? Guys, every time they say toy, I need to consider the cone and the hemisphere. Everything
And sir,
together. Yes.
with the sphere, the next volume, they give us the formula for the sphere, but we always have to, it's not just hemisphere, it has to be over 2.
You have to divide it by 2, yeah.
Well, guys,
Yeah.
those are the traps. Those are the traps. I'm happy that you are vigilant for the traps. Gabriel, David, Ashton, Otto, O'Driscoll, and Moses, you can lower your hands, guys. Thank you. All right. Thank you so much. Okay, guys, look here. They give us the formula for the sphere. That means it's all of that. That's the 3-dimensional circle. Are you following, guys? But that's not
Yes,
what
sir.
we're just looking for half of that. Now, the half of that is the hemisphere.
Divided by
Those
2.
doing geography will know hemisphere, you know, the basically, is it lines of latitude and longitude, right? So the hemisphere
sir.
will be, is the middle part of it. Are we following? All right. So this here that we're given is for the entire sphere. So whatever that is, you can halve that. Some of us prefer to halve the formula already before we start. I said dare to do that if your algebra is on point. But for me personally, my advice to you is substitute what you are given and halve the final answer. Does that make sense? So we're going to do it by parts, okay? So the first part here will now be my cone. Okay? All right, so this is my cone. All right, and then we will, okay, guys, let's listen, and then my sphere. So if I now look for the volume of this, I will now do what? Volume of that will now be equal to 4/3. Multiply that by pi. I'm putting it in brackets, guys, because that helps you to be safe when you do your calculations, right? So your radius, we said, is 3, and then you have to cube that. All right, so can somebody get us this answer here, please?
18 pi.
Okay, let's keep it as 18 pi.
36 pi, sir.
Is it 36?
56.
It's
Okay.
36 pi, but if you divide it by 2, then it's 18.
That is, okay, now I want you to give it to me as it is.
Why?
Okay.
18 pi.
pi.
Danny.
Okay, guys, listen. Okay. Not to avoid this confusion. This is for the sphere, all of it, nah? And then that will be 36 pi. But remember, we still have to divide that by 2 because it's half of that, right? So if we divide that by 2, that's how we get the 18 pi. So 18 pi is what we're looking for. That will be for this hemisphere here. Is that making sense?
Yes, sir.
Pardon?
No, sir. So I want to find out how we finding 36 pi, because my calculator would show me
Just-
100.
Okay, I think I need to get a calculator here. So that means 4/3, and then we've got the pi there. Please use your brackets, guys, and then you can even put the pi in brackets, and then we put the 3, and then we cube the 3. Okay, when I cube the 3, but then you just punch it in like this on your calculator. If you do that correctly, this is giving you your 36 pi. Please put brackets.
4/3.
4/3,
Yes.
open bracket, pi, close bracket, open bracket, 3 to the power of 3. It must be cubed.
It must be cubed. Okay. And then, sir, it's still giving me 112.
No, Danny.
Press
no, I press it on my
change.
calculator. No. Okay,
Because-
130. Okay, sorry, Danny. I thought you were getting another 123 pi. Listen, if
Oh.
you leave it as decimals, it will be 113.08.
Yeah.
Now,
When-
the learners, listen, your question about pi, yeah? This 113.09, the full display on my calculator is 73355. Now look here, guys, this whole thing here, some of you might round it off to 2 decimal place, some can round it off to 1 decimal place, but if you put here 36 pi, that is more exact. And then you divide that by 2, that will be 18 pi. So that's the volume of it. Keep it like this until you add it to the volume of the cone that we have on top here. So
Yes,
for the
sir.
cone, we will use that. So if we use that and plug it in, we'll say 1/3 times it by pi. My radius is 3, which needs to be squared, and my height was 4, right? So if I punch this in my calculator, what do I get? So I say 1/3.
12 pi.
Guys, don't just sit like that. Put it in the calculator as we're going through this together, so that you also gain some calculator skills, so that you can see. But my calculator is not giving you the same answer. Maybe we can see that your calculator might not be in the correct what is this, in the
Setting.
correct mode. It must be in the mode. So that will be 12. Okay, so now what do we do now? If we have that, then we say 12 pi plus then my 18 pi.
18 pi.
So what is it? 12 plus 18 will give you
It's 30 pi.
30 pi. What does 30 pi mean, guys? It means 30 multiplied by 3.142, that whole number. Or if you want to use it as 30 times it by 22/7. Basically, it means 30 times 5. Are you following, guys? So if you say 30
Yes,
pi,
sir.
or you
Sorry,
could put
sir.
it as, if you put it in the decimal form, it will be 94.24777 So you could take it to 3 significant figures, maybe 94.2. That's also okay. But the Lanas,
Sir,
you see
wouldn't
that
it? Yeah.
30 pi is more exact. Are you following the Lanas?
Yes, sir.
Okay, perfect. Okay, so now that part is fine. So we move over to the next part. Then they say the totals, I mean, the toy is painted. Now the surface area, calculate the total surface area of the toy that has to be painted. Now in this case, just look at the shape. Let me just put the shape down here. So this is now my cone and this is my hemisphere. Guys, when we talk about the surface area, it is just the outside, yeah? Okay? But the good thing is they give us the formula here. So the surface area of the cone, that's there. But the total surface area, again, they will only give us for the sphere. So what do we do again?
have
We
to
need
half
to
that.
divide that by 2 again. Does that make sense? Are we together, guys?
Yes, sir.
Wait.
Okay. Perfect. Now, listen, guys. What I want to do now is let's answer this question from the drawing itself. So you have to give me the formulas now. You have them on your paper there, so that you understand
sir.
what you're trying to do. Okay.
Sure.
So, okay. Now look here, guys. As I said, I want to quickly show you something. Let me put this away. We must have a sphere here so that you can understand what this means now. I hope I've got a sphere somewhere here. I thought I had one. I don't have a sphere. Wow. Okay, that's strange. Okay. Looks like we do not have a sphere. But I think you all understand what a sphere is, right?
Yes, sir.
Yes.
Yes, sir.
Okay, good. So now, in this case, what do they want us to do here? They want us now to find the total surface area. Now, the surface area, let me just put it as a cone. What was the formula that we're given?
Pi RL plus pi R square.
Perfect. And then we're going to take the surface area of a sphere.
Which is 4 pi R square.
R squared. Okay. So do you see what's happening here? If I look at them separately, right? So I'll say, in this case, I've got pi, which is just pi, multiplied by my radius, which is 3, multiplied by my slanted height, which is 5. So all of that has to be added to pi, multiplied by the radius being squared. Are you following, guys? So basically, here I have 15 pi because 5 times 3 is 15, plus then my 9 pi. So all of this will be equal to what? 24 pi.
Which
Are
is
you following?
24 pi.
Oh, now I see.
Now this is
Okay.
the total surface area of the cone. Okay. Now from here, okay, total surface area of the sphere. So we have 4 pi multiplied now by my radius, which is also 3 squared. So it's gonna be 9. Okay, so 4 pi, if I put it on my calculator, multiplied by 9. So this will be 36 pi, isn't it?
Yes, sir.
So then
And then
I
you
now
divide
need-
it by 2.
Exactly, perfect. So I need to divide that by 2 because this answer is for a complete sphere. This is just a hemisphere. So dividing
So
that by
basically
2 will
two
be
halves of that hemisphere is
Exactly.
equal to 36 pi.
Exactly. So this will now be 18 plus this. So what do you get if you say 18 plus 24?
42 pi.
42 pi. So that will now be the total surface area. Since it's in centimeters, it will be centimeter squared. Okay. Are we fine, guys? Let me see
Sir.
thumbs up. If it's clear.
Sir.
Yes, sir.
Oh, sorry.
Sir, I have a
Put
question.
Sir, wiped out something, sir.
Put
But
up your hand. Put up your hand. Who said they've got a question?
I have a question, sir.
so I can't
Yes.
put up my hand. but
Hold on,
I'm-
Alessandra, you've got a question. Let's hear.
Sir, at the surface area for the cone, should we say pi r squared? Because that's for the base of the cone. Are
You
we
see
using
the-
the base of the cone? Like, are we
The
painting?
surface area. Now you see what's happening here, Alessandra. This formula that you are given there is for the surface area of the cone. If you look at the question, let's quickly go there. They are telling us that it is for the surface area of the cone. Okay. Now, what happens here? What happens here, guys, is if you are painting the toy, it's a very, very good question. I'm happy you asked the question. Huh? That's why I was saying you must always see that you must paint the outside. Does that make sense? Okay. Now, I need you to listen very carefully. If this is the base, now I'm going to draw the base with red. Okay. And then this is the cone. Are you following, guys? Okay. Sorry.
Yes, sir.
Doesn't want to work. All right. Now, imagine this is 3D. So the outside of that, you are painting like this, right? And then the sphere, I mean, the hemisphere is down here. And then you're also painting the outside of that. Now, what she's asking is very good. And I'm happy somebody asked that. That was the next thing we had to look at. Because you're only painting the outside and the outside. This cone, this formula that you have for the cone is when it is standing alone. You understand? So it is obviously painting the base as well from underneath. But now in our case, that is on the inside. So you still have to come and say pi r squared, which is the inside circle, right? And then you have to take it, was it 44 or 42?
42.
42 pi. You still have to subtract your area of the circle that you have down there. Does that make sense, guys?
So, sir, we're not allowed pi r
Pardon?
squared. So I'm just asking to confirm. We subtract the pi r square
Because no, it's a very good question. Now my thing in this question now from here onwards is let me just admit these two friends of yours, and I want us to, you know, once you understand this question fully, it's going to help you to see how are you going to put this together. How are you going to put this together? Because your what is this? Your sphere as well as your cone has the middle part in there. Are we together? Right?
Yes, sir.
All right. And they share this middle part. Does that make sense?
Yes, sir.
All right. So which means that if you take that middle part away because that part you will never paint, right? So if you take that middle part away, what does that mean? It means that you're taking away from both the cone as well as the hemisphere that you have down there. Does that make sense, guys?
Yes, sir.
Okay. So you need to find the area of that, and that is what you need to take away. Does that make sense?
Yes, sir. I just also want to ask, if they don't
sir.
say it's to paint the outside and they just ask for the surface area, do you still have to subtract
just
that?
the cone, only the cone, or what?
No, for like just the surface area of the toy, but they don't specify only for the outside. Do you still take away that?
Yes, because that part is not on the surface. It is on the inside.
Okay, I'm just asking.
No, it's a good question. That part is
Because
on
if
the
you put it
inside.
out into a net, then like where you normally calculate the surface area, then
So,
that
but
would
if
still
we're
be
gonna
part of
remove
it.
it, why do we need to put it there?
But
In the
Because
first
why
the
I'm
formula,
asking
that you are given, yes, you first get everything because the formula that you are given, the formula that was already derived for you, the formula that you are given that was already derived for you had it as part of that. Does that make sense?
Yes, sir.
Okay, because you do not know how to get the formula for what is this called? The formula for the the surface area or even the volume of either a cone or a, what is this called? A hemisphere, for example. You do not have that. So you have to take it away. Either way, you have to take it away. Does it make sense, guys?
Yes, sir.
Yes, sir.
Now, my question to you is, now let's get the final answer. I want to know what is my final answer. Guys, are we together?
Yes, sir.
Yes, sir, we are together.
Yes, now I want the final
But,
answer.
sir,
Because
my
you-
hand was also up.
Don't scream.
Okay.
What is your final answer?
Where, sir?
Well, sir,
for the question that
before,
you have there.
sir, before subtracting anything, I get 39 pi.
Pardon?
Before subtracting anything, I get 49 pi. Or 39 pi, sorry.
No. Before, no. Listen, guys. I want you to be very careful about this, guys. Listen, the answer we got in the previous part here, this 42 pi is correct.
Yeah.
But the problem with this 42 pi here is it includes that middle section. It includes that as well from the hemisphere at the bottom here, as well as the cone on top there. So what you are saying is this that you've calculated.
Yes, sir.
Yes. So what do you need
You get 42 pi.
But sir, the previous one is volume, not surface area.
Pardon?
The previous question
no, we're
is
not
volume.
talking about that.
No, we're not talking about
Okay,
that.
sir. After you subtract the pi radius square, I get 33 pi.
33 pi is the correct answer.
But, sir, how?
Guys, listen. I think we've got enough time there. We are in a good space, and I'm happy that we're engaging in such type of questions. Alessandra, thank you for bringing up that question. The next part of my idea was to prompt that question. I mean, to prompt that so that we can get that out. All right, now listen, guys. I want you to please listen very, very carefully. Yeah? Okay, so if you were not listening, I want you to give me your undivided attention. Okay, everybody, because if you listen, guys, then you would not struggle with this question. You will completely understand what I'm trying to say. So let us please listen there. We've got 2 ears and 1 tongue. We listen twice as much as we talk there. That's the reason for that. Okay, so now look here, guys. This formula that you are given, and this is the difference between getting an A star and an A, because these are the things whereby you can lose marks whilst you think that I aced that paper, I've got an A or an A star. The surface area of the cone has a set formula. it was already derived for you, okay? Now, what you need to understand about this is this set formula was just the cone on its own, okay? Now, I'm gonna try my best to draw a cone, all right? So now, if you have the cone like this, okay? Right, so now you have a circle here at the bottom of the cone. So what it means here is that this part on the outside, now, imagine I'm also going around because it's a 3D shape, as well as the base from the bottom part. This formula entails all of that, okay? And now, if I now look at a hemisphere, so let me draw the hemisphere here, and then you have this over here, okay? So this here, these two things are linked together because they are shared here between the two. But now this is on the inside. Are you following? So what I'm saying is when you put these two things together, it is the same size. So when you are painting, you need to remove that part because this formula was for the cone on its own, okay? And then this formula that we have on this side was for the for the sphere on its own. And when we divide that by 2, we got it for the hemisphere. So when you remove...
Where does the 42 pi come from, sir?
Yeah, but then where does the 42
pi?
come from?
Okay, hold on. The 42
Yes.
pi comes from the total surface area, right? So you work out the total surface area by using the formula that you were given.
But wait,
right?
wait. He
Everything
said that
added
you have
together.
to divide 24 by 2 and 18 by 2. Yeah.
No. 24 doesn't get divided by 2. Only the 36 from the sphere gets divided by 2. Then you've got the one for the hemisphere. Then what you have to do, you add them together and you get 42 pi. Where the 42 pi turns into 33 pi is where you take out this pi r squared from the formula of the area of the cone, the total surface area of the cone, which would be pi times 3 squared. So then that would be 9 squared. So then 42 minus 9 squared and minus 9, sorry, 3 squared 9.
Okay. Okay. I get you.
Here's my question.
I get you. So
Danny.
you had to
Danny, can you stop screaming?
Okay.
Danny, please. Here's my question. If you're adding to subtract, like you're already gonna subtract, so why you need to? Why can't you just exclude the pi r squared?
Just exclude.
That you can. It's just like
I don't even know what you are talking about, to be honest.
we've left
I'm
right
slow.
now, but like
I'm just saying, why can't you just exclude the pi r squared since you're going to subtract
because
again?
it's on the inside.
Yeah, I think it's better.
Otto, verstanji. Verstanji.
Mia, listen up. Mia.
Yeah, what's up, Danny?
Okay.
Okay, guys, I hope you can still hear me. Sorry, my network just went AWOL. All right, are you able to hear me?
Yes, sir.
Okay, hold on. I think you can hear me. Let me just, I'm on the other laptop. Can you hear me? Let me see if I can hear you.
Yes,
Yes, sir. Yes, sir.
Okay, good. I'm so sorry. My network just went off a little bit, but let's go further. Yes, Danny boy, your hand is up.
Sir, I think, sir.
Danny, stop screaming.
Okay, relax. Okay. Okay, so sir, I get everything that's going on right now till this point. I just need us to go check at number 1A, I, the volume.
Okay, we can go. Yes, we can go further. We just want to make sure that everybody understands what's happening. Okay. Good. So if we understand the fact that we have to remove the circle on the inside, which is common to both the cone and the hemisphere, then we
can't see anything.
The surface area. So I shared the screen. You should be able to see the screen now.
I see.
Okay, good stuff. All right. There's nothing blocking the screen there. Everything is clear.
Yes, sir.
Okay. Good. Danny boy, lower your hand and let's continue with the question. Okay,
Okay,
so
sir.
I think that part is fine. So let's go further. So the answer should be equal to 33 pi. Alessandra, is that what you got?
Yes,
Got
sir.
that. Yes, now.
Okay, okay. So we had to remove the circle over here. So that's perfect. I'm loving this, guys. We're going to ace that paper tomorrow, ne? That we
Yes,
win
sir.
it in our mind first. All right. So now we go further. They say a tin of paint will cover. So which means it's 1 tin times 1, right? Will cover a surface area of 22.5. All right. Now, how many tins do you need to paint? Now, guys, that's where the pi part. Either you put it like this or you put it the other way around. Are we following? Okay, Guvi, you've got a question or your hand is up, Guvi?
Yes, sir.
Okay, there's a bit of network issue there, Guvi. I can't hear you. Can you
Yeah.
repeat yourself again? Guvi? Guvi, say again.
Meow.
I think that
In the previous
in the previous question where we got the 33 pi, sorry.
yes, sir.
Yeah, okay.
What about it? Yes, let's hear. You are asking what?
Yes.
So I can't hear you.
Yeah, I also can't
Yeah,
hear
order.
her.
Sir, I think, yeah, because
Okay, Alele, I hope I'm saying your name correctly. Alele, can you change your name to the name we know you at, nah? Who is Alele? I see you also got 33 pi.
Say it's Antonio.
Antonio. Antonio, change your name, and the Zoom is recording some data, né? So I want to see, because it will show who was in the class from what time to what time and the data, né? So please just put your real name so that your parents can see if I share the sheet. Okay, thank you. All right, so Guvi, I couldn't hear what you're saying. So she was talking about the previous question, but whilst we're waiting for her, Danny, sorry, not Danny, but Genuine, your hand is up.
So going to the previous question, when we did the total surface area for the cone and the surface area for the sphere, I just wanted to find out, are they two completely different, whereby you have to minus the pi r square from each of them?
No. Because they are having it in common, right? The cone from the top, right? This is the circle that they have at the base, and that same circle is also part of the the hemisphere. So you only subtract it once.
Okay, thank you.
Yeah, so you will only subtract it once, okay?
Okay, sir.
Okay, perfect. All right, Danny, your hand is up.
Sorry, sir. I was asking a question previously
Danny, listen, Danny. Some people have headsets on, so that's why you do not need to shout. We can hear you loud and clear.
Shout.
Just talk, man.
Oh, maybe, sir, my voice is too near the speaker, but it's fine.
Okay.
Yeah, sir. I was saying, at number 1A, right? Calculating the volume of the toy. I was a bit lost there.
Okay,
Number one.
Before I go back to that, Guvi, it's the same thing I answered Genuine now, ne? Because these two things are linked together, they fit one on top of the other. So they have the same base. The base of the cone is exactly the same size as the base of the hemisphere. So you only take it away once. Does it make sense, Guvi? You can just give me a thumbs up if you understand what I'm saying. Okay, thank you, Guvi. All right, so Danny, you were saying which question? The previous question. Which part?
Yeah, number one A, the volume of the toy. I. The
okay,
one
so
there.
room 3, volume of the toy. Okay, now
Yes.
look here. the volume of the toy is you've got the volume of the, sorry, let me just do this. All right. So Danny, what happened here was we got the volume of the sphere, which is the whole thing, the three-dimensional, what is this? The three-dimensional, by the way,
shape.
Yeah, let me do the following. I want you guys to just imagine something here. Not imagine, but maybe if you visualize this, it'll make life much easier. Nah? So just give me a second. Just give me a second, okay? Okay, I have something on. All right. Okay, just give me a second, because it makes it easier, because this type of questions are very, 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 very common. So if you get the hang of it, like the way, you know, Brendan, when we started with that question, you spotted that, yes, this is what I need to do. First of all, I must remember that the formula I'm given here is for a sphere, and not for a hemisphere. All right. So we need to first understand that part. Okay. So guys, where is this now? Let me just see if I find this thing that I'm looking for. Yes, I think it should be somewhere here. Just give me a second. Okay, I want you to, you know, some of us can maybe assume that we know what a sphere looks like. I had a question. It's just a pity that I never included that question in my collection here. Okay, but just give me a second. I'm sure I'll find it. It's just my question paper bank it's just so many questions. And the reason, okay, Antonio, I saw your question. The reason why we're working with pi is because it's exact, especially in your workings. Before you get to the final answer, the pi is exact. So instead of writing a lot of decimal places and so on, it's just easier, very, very easy. Okay. All right, guys, perfect. So listen, yes, I am also seeing what you are sharing in the chat box. So if things are not clear, you can always in the chat box as well. So guys, do you see my screen now?
Yes, sir.
Okay, now look at this. I'm gonna zoom this. What is this, guys? What do you see there?
A sphere.
Exactly. So here, look here. They are telling us a sphere here has a guys who's moving around like that, please sit still. Has a diameter of 12 centimeters, right? So it means the diameter is not just from the radius here, just up to here. Okay, unfortunately, I cannot. Okay, let's just get a straight line. So the drawing, let me just do this. So from the center to anywhere on the circumference of that's the diameter, right? But it doesn't stop there. The radius, sorry, the diameter are from one side to the other. Whether it's like that horizontally or whether it is vertical, that's the diameter. So if the diameter is 12, what is the radius of this?
6.
Exactly. So the radius is 6. Okay. Now, besides all of this, guys, what I'm trying to show you is this is a sphere. The hemisphere will now be half of that. So if we cut this thing in the center here like this. Okay, I'm not cutting it nicely. Maybe I can start here. If I cut it in the center like this, then I've got the sphere here. One part is up here. That can be number 1. And that can be the second part. Does that make sense, guys? Are you together?
Yes, sir.
Yes,
so
sir.
if you were getting the volume of this, you can just plug it in like this. You see, they gave it to you as diameter. So the radius has to be 6 in this case. So you plug in 6 here where r is, you cube that, multiply with pi, multiply with 3/4, you get the entire volume for the sphere. So Antonio, I hope you're following this part, okay? That's the sphere. Now in our case, if we clear all of this, all right, let's just do this, all right? Let me close this and then I just zoom out a little bit. In our case, imagine, maybe I can just edit it here and then just show you. I hope that this thing can edit parts, né? Unfortunately not, because I wanted to take a part away from here, but unfortunately we can't do that. So anyhow, or let's rather do it like this, okay? Let's make it a bit small, okay? It doesn't help. Then we have to make both small. Let's do it like this. Okay. I skipped the other one, sorry. Okay, but due to time, what I want to do on this picture is I want to draw the cone that we have on the other side. So if I draw the cone here, don't imagine the top part, né? The top hemisphere. So you see this section here is in common with the hemisphere over here. The cone is there. Does that make sense? So Antonio, what we're saying is for the volume, we get the volume of the cone. Unfortunately, I'm using the mouse to write here, so it's ugly. And here for the volume, we use the volume for the hemisphere. So even if you take the volume of the sphere here, you still have to divide that by 2 because it's hemisphere. So that you add these 2 volumes together, then you've got the total volume of the entire toy. That's what we're talking about. I hope that is clear, guys. Are you following?
Yes, sir.
Okay. Now,
yes,
in our situation, I'll stop sharing that one now. Then we go back to this guy. All right, so that we can share. All right. Now, in our question,
Yes, sir.
yes. Yes, is there a question? Guys, I heard someone was calling me.
Yeah, but then the person mute.
Okay, Danny, you can lower your hand.
Oh yeah.
Okay, sorry, my screen sharing is just quickly updating. I think it will show now. Okay, so guys, this is what I want to avoid, because some people that are genuinely listening, we are wasting their time. And some of us that are not listening, there's a difference between understanding something whilst you're listening and not understanding something because you're not listening. I know even in class, some of you are doing other things while you are busy with another question. And then you come back and say, I didn't understand how we get that one. Then you want to ask the question again. And we want to avoid that, guys. Time is not in our favor. Né? So what I'm saying is, can I do the volume of the cone on this side? So if we say the volume, it was surface area, nah? Sorry. So the surface area of the cone. So the surface area of the cone is on this side. And then we say the surface area of the half of a sphere, which is your hemisphere, is on this side. These formulas are given, guys. They are given. You know your radius. Plug them in and you get your answer for the surface area of the cone. Plug into the the sphere here. Whatever answer you are getting here, I think it was 36, or I can't remember. You divide that by 2 because I explained that this is a half of a sphere. When you add these 2 things together, you get the total surface area, of everything. But this is the inside. So you have to subtract from that you added together from the cone as well as from the hemisphere. You subtract that of the circle. Okay, guys, this thing is on YouTube. I will repeat. You can always go and look at it. Otherwise, we're doing injustice to people that are listening there. So let's go on.
Okay, so let's go on. It's on YouTube, yeah.
Yes. We can't spend so much time on one question. So once you have subtracted, that was 33 pi. So the 33 pi, if we put it into a decimal form, which I say on your Casio calculator, you press your SD button there, then it gives you a decimal. Once you have your decimal, then you know 1 can can cover that, right? So you divide all of that by what one can cover so that you can work out how many cans you can possibly have. Now remember, if I take that, for example, I say 33 pi, divide that by 22.5, on my calculator, I'm echoing somewhere, guys. On my calculator, I get 4.60766925. Now, if you want to paint and make sure that you paint all of them, if you need about 4.6, you are going to buy 5 tins so that you overcompensate and you've got more than enough. Because if you only buy 4 tins, you'll run short of the 0.6 centimeters squared. So then you will have 5 tins over here. Guys, thumbs up if we are together.
Yes, sir, we are together, sir.
Okay. All right. So yes. Okay. Thank you, Antonio. Right. Yes. So we had to remove that. That's why we get the 33 pi. Perfect. Okay. So from here, what was the other one? Still on mensuration. Are there some questions on mensuration? This is now not here next to me. Can I scroll through this and then you can tell me? Can I skip this?
Yes, sir.
Okay. What was the other question?
4 tens. 5 tens or 4 tens.
7, sir.
Okay.
What's the question 7?
And 10, sir.
Yes, sir.
Question 7 and 10. Where is question 7? Is it this 10?
Yes, sir.
Okay. Now let's quickly look at this. All right. Now, in this case, look here, guys. They are telling us the following. Let's just get the pen out. They're saying the radius here of the inscribed, is inscribed in a square. So this is the circle that is inscribed. So it's within the square. Are we together? All right. Now it is showing us that the radius is 9, and that's what the picture is showing. Perfect. Now, after this, they say, work out the area of the circle. So area of the circle is pi r squared. So you'll say your pi and your r here will be 9 squared. Are we together? So it will be 81 pi. That's what you will have, isn't it? Are you following, guys?
Yes, sir.
All right. So you can have it like this. If you go and multiply it with a pi and you want to put it the other way around, you can also have it as 254.469. We can round it off. If it's 3 decimal places, you can leave it as 254. Okay. Are we following, guys? Now the area of the square. Now remember, guys, the area of a square is side times side. Now, if the radius is 9 and the diameter will then be 18. So this side is exactly the same as that. So if you look at this, you'll see that here is the 18, 18, 18, 18. That's a square. So basically, what are we saying here? We are saying 18 times
18.
A legend.
324.
Yes.
Centimeters. Square centimeters. Yes, sir.
Yes, sir.
Yes, sir.
Yeah, you doggy.
Oh, Brad, man, cannot give you.
Sir, we can't hear you, sir.
So we can't hear, sir.
Can hear, sir.
Okay. Oh, sorry, guys. Sorry. My thing
Okay,
was...
now we can hear you.
Okay.
Sir.
So what I'm saying here is, look here. The one that I've colored is for the square that we have over here. So that red one is for the entire square, the area of that square, which is what we calculated to be 324. Are we following? Which is here.
Yes, sir.
Yes,
but
sir.
Now the volume, not the volume, the area of the circle is 200, that, right? So what does it mean? If I now come and I take the area of the circle, I remove only the blue part. Nah? So that means I will now say 324 minus my 254. So if we say 324 minus my 254 gives you 70. Are we following?
But then you have to divide it by 2 because there's only 2 shaded corners.
Exactly. And that's what you look at,
Which is
because
then
that
35
70 centimeters square includes, look here, it includes that part, it includes that part, it includes that. So there are 4 of them. But from the 4, only 2 are shaded, only that and that are shaded. So because it's a perfect circle, that 70 has to be divided by 4. If you divide that by 4, each side will now be equal to 17.5. So times it by 2, or you could just simply divide this by 2. So that will be 35 centimeters square for the shaded one. So how do you show this? By saying 324 minus the 254, divide that by 2. That will give you your 35 centimeters square. I think those are easy 6 marks, guys.
Yes, sir.
Okay.
That area is 6 marks. Yeah. Oh.
Okay, so we can go here. Graphs in practical situations is under which topic? Are they? Is it under
No,
part
wait,
3?
sir. Can we just do
So can we do question 7 in the
page
next
5,
Oh, yes, sir.
number 5, B2?
Number 5, B2. Is it from the previous question?
No, sir. It's more forward.
Oh.
And after that,
Okay,
we
is
do
it under this one?
Yes, sir. This one.
Okay.
You can't see it.
Okay. Let's look at this. Okay, guys. So B2. Is A okay, guys? Are we all fine with A?
Yes, sir. A is okay.
Yes, sir.
No, sir. Yes.
No, sir. No, sir.
No, sir. That is number 1.
Okay.
Number 5 is
Now,
Let's
okay,
just do
guys,
the whole
let me-
thing.
Let me just put it here on the side. Okay, guys, listen here. Listen here. Now, we've got an irregular pentagon. Penta means there are 5 sided. So it can be 1. Okay, let me just draw it like this. 1, 2. It doesn't work. Okay, 1, 2, maybe 3. 1, 2, 3, 4. And then the 5th side is like this, maybe something like this. Okay, guys, look at this. Every time you have this kind of questions, try to draw it and see if it makes sense. So let's say, for example, this one here is X degrees. All right. And then we say that maybe this one here is 104 degrees. And then we say that this can be 85 degrees. I just tried to make it realistic now. So it looks like maybe acute. This is a little bit over 90. And then we say that this one looks like maybe the 2x and this is the 3x. So you put in all 5 angles in that pentagon. Are we together? All right.
Yes,
okay, now what I want you to do now is to look at the following. If you make this longer over here, right? Then it means that this angle plus the one inside are supplementary, because this plus, maybe you even put it as y or whatsoever, that angle y must add up to 180. That's one part you also need to take into consideration. Okay. All right. So the other thing we also need to take in, if you go ahead and you do it for each of the angles, that means all these angles on the outside, they will also be 5 because they have to add together with them. 1, 2, 3, 4, 5. Are you following, guys? All of those angles on the outside always adds up to 360. So that is a very important property we need to understand. Are we all together, guys?
Yes, sir. Yes, sir.
Okay. All right. Now my question is, how are we utilizing that property to answer this question? What do we need to look at if we are utilizing that property? How will we get the size of one of, actually you need to get X. Once you get X, then it's easy for you to calculate anything else. How will you find your X? Just quickly, guys, those of you that have answered, can we have input? Yes.
So what if you minus 140? No, 14 from 180.
104 from 180. So basically what you're doing is to find that angle there.
Okay.
No, to find x, because like it has to be equal to 180 if you plus them together.
Okay, you are somehow on the right path, but not completely.
Sir,
Yes.
so the way I did it was to find the interior angle of a polygon, which is a pentagon, sorry, which is 540, and then you just say x plus 3x plus 2x plus 104 plus 85 equals 540, and then you can work out what x is.
Okay, now my question for that, guys, does that apply for irregular shapes or only for regular shapes, where all the angles and all the sides are the same?
No, so they're not all the same, but the interior angle, like all the angles will still add up to 540, even if they're not all the same.
Yeah. Okay. So she's saying that if I add all of these angles up here, they must all add up to 540. How did she get that?
Yeah.
So the formula,
What is that formula?
n minus 2 times 180.
Interior or exterior angle, sir.
So 180 n minus 2.
Yes, sir.
So that is going to give you, because what is n? N is the number of sides.
Yes, sir.
So basically, whether it's regular or irregular, they must all add up to the 540. So if there are 5 sides here, then it will be 5 minus your 2, which is 3. 3 times it by 180 gives you 540, right? So from the 540, what you'll do is now to find x. You'll say, if I add up all the angles, the 104 plus the 85 plus then my 2x plus then my 3x plus then my x, all of that must add up to 540. Then you put all the x's together, all of this to the other side, and make x the subject of the formula. And then what will your x be?
58.5 degrees.
How much?
58.5.
38.5. But that's not the answer to the question. They want to know what is the smallest.
You can also say x plus 2x plus 3x plus 104 plus 85 is equal to 540. Then you use the equation to find out what x is.
Yes, that's exactly what we said up here. That's what we said up there. So it will be 6x will be equal to 504 minus the 104 minus the 85. So she said 6x is equal now to all of that. Divide that by 6 should give you your
58.5, sir. So 58.5.
38.5.
No, 58.5.
Or 58.5. Okay. So now listen, you've got 5 angles. One angle is 104, one angle is 85, one angle will be 2 times 58.5. This one over here, one will be 3 times 58.5. Because of this, the x will just be 58.5. If you say 2 times 58.5, what do you get?
117.
Yeah, so 58.5 times it by 3 is going to give you
117.
175. Okay. Yes, here's 117 here.
Oh,
and
yeah.
This is 175 point that. So you now need to compare between this 1, 2, 3, 4, 5 angles. Which one is the smallest? So the smallest angle here would be the x itself. So then your answer will just be 58.5. That's okay. Is that making sense, guys? Are we all together?
Yes, sir.
Sir, sorry,
Yes.
Sir, to understand the equation, how did we get 540?
By saying 180 times it by n minus 2, where n is the number of sides for any polygon. So we had 5 sides because it's a pentagon. 5 minus 2 equals to 3. 3 times by 180 gives you 540. It would also be the same case if you're multiplying with a 6-sided shape. So your n would be 6. If it's a 7-sided shape, your n will be 7.
Okay, sir.
Okay.
Okay.
So
let me just
that part was fine. So we look at the next question. So the next question, you said now, the diagram here shows a polygon A, B, C, D, E, F inscribed in a inscribed is inside the circle with a radius of 8. Are you following? Now the fact that it's in a circle, that already means that this is a regular, how many sided shape? 1, 2, 3, 4, 5, 6. So what do we call the 6-sided shape? Hexagon, yeah? Okay, so now write down the name of this geometrical shape. We've done it then, eh? Hexagon. So hexagon. You get that?
Hexagon.
Find the area of the shaded here. Now, guys, when you have to find the area of all the shaded one, what do you need to do? Find the total area of the whole circle, all of it, and then you subtract the area of the hexagon. Because the area of the hexagon that you are having over here, this is your hexagon over here. All right, so if you take away all of this, then the only thing that will be left are the shaded area. Now the question is, how do you find the area of a hexagon?
Yes.
So you can divide it into equal triangles.
Okay, so you can take your ruler and then we can now start. Maybe we take this into this triangle over here. So we can start by saying, okay. So I think you can start by saying, all right, so from here, okay, hold on. Let me just put it like this. I hope I can draw, sorry, I need to take the pen, sorry. So this can be one triangle, which is your FAB, okay? FAB, are you following? Okay. Okay, and then we can have another triangle over here. Are you agreeing? There is another triangle, which is your FBC. And then we have another triangle over here. If I draw from here to here. Okay, now look at these triangles here. I've got 1, 2, 3, 4 triangles.
So can you not just add the equilateral triangles? Sir? I
am Moses. I said the Janie. Shadea, what is our now?
Are you all
Yes, sir, we're following.
Sir.
Okay, all right, guys. Are you aware? Listen, are you aware of another formula that we can use when you have the number of triangles? Yes.
So could we also have instead of, do we have to split it into triangles? Because could you also split it into 2 triangles and 1 rectangle?
It depends. If you got sides known to it, you can have it at different ones. Okay.
Okay.
But can you just use the 6 equilateral triangles, sir?
Yes.
How do you get the 6? Pardon? I didn't get what you're saying, Moses.
He said that you can also have 6 equilateral triangles.
Okay. Yes. So how will you then divide the 6 equilateral triangles? So I can
From the
then take
center
it out.
to each point.
Perfect. So that's actually another way of looking at it, né? So you can take it from the center. Okay. So if we take it from the center, let me just get my pen correct so that we can have it nicely. Okay. All right, so let me take it away like this. Okay, thank you. So now we're going to connect here. We're going to connect from here to there. All of them must go through the center now.
Yes, sir.
Okay, perfect. So we're going to connect from here to here, and then we're going to connect. All right, just hold on. From here to there. Okay. So which means all the sides here are 8 centimeters because they are all starting from the center. You see, they are all starting from the center, and these are all radii. Né? So you've got equilateral
Yes, sir.
triangle. Okay. So how will you then work out the area?
So it's now half base times height, I think.
Yes. Yes,
So
but
it's-
listen, if it's
and
if
then
it's
times
an
6.
equilateral triangle will always be 60 degrees, nah? 60
Yeah.
You
degrees
can
for all
also
the angles.
say
The lateral triangle will always be 60
half
degrees.
so
8 times 8 sin,
So you'll say
times
half
sin
times side
60.
AB sine of A. Do you remember this formula for
Yes,
calculating
sir.
the area of this? I'm sorry, this must be C. Are you following? Okay,
Yes, sir.
so this AB means it's the included sides with, I mean, the included angle with the two sides. So in our case, what we will then have is this side and that side. Those are the two sides that are including this angle here. So when you substitute that there, you will now say half times 8 times 8 and then sine of 60. So when you do that, then that means that you will then get the area of one of those 6 triangles. So whatever that area is that you are getting over here, this whole area that you're getting here, you multiply that by 6. Does that make sense? Because you've got 1, 2, 3, 4, 5, and then 6 triangles. Does it make sense?
Yes, sir.
So
Yes,
it's
sir.
it's basically you are basically saying
my
half
calculator
times
mode.
your 8 squared times it by the sine of 60. So if you do that correctly, what do you get? I think I'm getting 34.
Cosine.
Not cosine, just sine.
Okay, sir.
Just plug it into the calculator the way we are having it over here. If you plug it into your calculator like that with sine of 60, let me plug in, then one triangle is
27.7.
Sorry, I got a different answer. Sorry. This is not the answer.
27.71.
Yes, times that by 6 will give you 166.726877. So if you have 166, that's also okay. The 3 significant figures. Does that make sense?
Yes, sir.
Yes, sir.
Okay, good. So please don't write on my screen, guys. Okay.
Doctor.
All right, so I can skip this one. This one is fine. Then we can move on.
Sir.
Wait, sir.
Yes.
So why is your answer not 34.8? Quickly explain that part again.
Which one?
Gomez, your answer needs 34.8. Quickly explain that one again.
34.8.
Mm.
No, I'm not. I'm actually not done with it. That is just the area. Listen, this is just the area
Now
of
we
the.
have to subtract
Yes.
the full area of the circle
Yes.
with the
So this is
area of
just
that.
for the hexagon. Nah?
Okay,
So
do
we
the
still
next
have to
question.
say the area of the square minus, the area of the circle minus the area that I had here. So if I press in, let me just quickly press it on my calculator. So if I press it on my calculator, 8 being squared, and then I say sine of that, that gives me, multiply that by 6. That gives me 96, square root of that. Okay. If I put it the other way around, this value is the same as 166.7268775. And then my pi multiplied by the radius of 8 squared Wait, so if I subtract those two from each other, then I should get the final answer. Does that make
Yes,
sense?
which is 34.8 if you round it off.
Yeah, boy.
Huh?
That's the right answer.
Oh yeah.
Is that fine, Gabriel? Antonio, please stop writing on my board, man. Antonio, you need to focus
No,
in
yes, I
class,
understand.
please.
Yeah, Antonio. Antonio. Stop
Please
it,
stop writing on
Antonio.
the board, man.
Antonio, what's wrong with you?
Okay, it's fine, guys. It's fine.
No.
All right.
Maybe he wants to be the teacher.
Yeah. Okay, but anyhow, that's the final answer. So let's move on. Ms. Mugunda is back here, so she'll help me with the other questions you had. Well, the ones that are still under part 3. So let me see which questions were the others that we had to look at. Some of them that are highlighted. I think now we're moving towards trigonometry now.
Yes, sir.
No, sir.
Okay. This is still fine. Okay, Gubi also had some questions on graphs in practical.
Can we do the question that was after the last one that we did?
7.
Guys, which one?
Question
7. Question
Yeah.
7, sir.
Okay.
Question,
All right.
yeah, that answer, yeah.
So this is now
Diane and
angles in a
Dennis.
circle. Are you
Yeah.
following, guys?
Yes, sir.
Okay. So angles in a circle, let's quickly check. Let us fill in everything. So I'm going to summarize everything that we know about the circle theorems or the circle properties now. Okay,
Yes, sir.
I understand this is Genuine's favorite topic, huh? Genuine, is that the
I
case?
genuine.
All right, guys, let's start now. Let's start now. I need you to focus. So if you are coming from a point that is outside the circle, and then what you need to do now is if you've got a tangent line from that point, so we've got this first tangent line that is moving from B to C all the way up to P. And then you've got another tangent line from that point all the way up to A and then to L. What it means here is that this will be equal in length. That is a fact. Are you following, guys? Okay.
Yes,
So
sir.
if those two are equal in length and I've got a base over here, that means if we look at the bigger picture here, the green one here, then that means this triangle will be an isosceles triangle, meaning they got the same legs, which means the base angles here need to be equal. We already have that idea, nah? Okay. Now,
Yes, sir.
at the same time, at the point of tangency, here at this point where it meets at C, can you see that point here at C? With
Yes, sir.
the radius from here, that needs to form a 90 degree. Does that make sense?
Yes, sir.
So if it forms a 90 degree, that means let's look at the following. So that's just the one from the outside. But in the inside, look at the following, guys. This is my center.
Yes, sir.
Now from the center to the circumference, that's radius. This is another radius. So these two are also equal in length. Are you following, guys? So this
Yes,
is how they hide them. So these are equal in length. That means that this is also a isosceles triangle. Are you together? So if it's isosceles
Yes, sir.
triangle, the base angles here will be the same, isn't it? So
Yes,
this
sir.
angle here is the same as this angle over here. But now that triangle has this angle in the center as 105. So I will now say 108 minus the 105, right? Divide that by 2 will be equal to this base angles that I'm talking about. This one over here and this
Yes,
one
sir.
over here. Does that make sense, guys? 108
Yes,
minus
sir.
105 divided by 2 gives me 37.5. So this angle here will be 37.5. Does that make sense? Okay, so this will be 37.5. Now, since that is 37.5, then it means
Yes,
that this
sir.
angle on
This one.
this side will also be 37.5. But remember, we said at the point of tangency here, that whole angle is 90. So if you say 90 minus the 37.5, that is going to give you 52.5. So what does that mean? It means that this angle that I have over here will be 52.5. So will this be, because it's an isosceles triangle, 52.5. Does it make sense? Okay.
Yes, sir.
All right. So the other property that we also have, can I erase this? Are you putting this in your paper?
So I think
Yes, sir.
D angle, the whole angle of D, or not the whole angle, but like A to D, the angle at D, is half
At
the
B.
amount of 105. The one
Okay.
across from it.
Let's okay, but
Okay.
that's on the outside, ne? Mia, let's be careful on that one. I would rather use other properties to do that. I would
No,
take this
sir, not B, D.
D. Oh, yes. Okay. I thought you were saying B. Okay, so if it's D, it's fine. All right, so we've got that inscribed angle. Are we following? So what will we do now?
Yes, sir.
This one at the circumference, this angle that we have over here will be half the angle that we have over here. Are we following, guys? So if you have this, the way you need to remember is, you know, I'm starting at D. So if I come back to D from the center, to the circumference, and back to the center again here. Does it make sense? That means
Yes,
that
sir.
this angle at D is half the size of angle here at the center. So if you say 105 divided by 2, that gives you also
52.5.
That angle is 52.5. Does it make sense?
Yes, sir.
Yes, sir.
And at the same time, look at the following, guys. At the same time, I'm gonna just take this away. So we've got a circle in a semicircle, so I'm gonna rush a bit. So this is a triangle in a semicircle. All right, so a triangle in a semicircle, this whole angle must be 90. Get that?
Yep.
So if you say 52 minus the 90 there, that is going to give you 37.5 as well. So this angle that you're having over here, this angle will be 37.5. Are we following?
Okay.
Yes, sir.
Yes.
Okay. And then what else can we fill in? I think that's everything we can fill in. Okay, so
Yes,
if you
sir.
go back to the questions here, I've answered everything. And the reasons what you can give now is to say, for example, which one did we say? So for the first answer here, let's just put it down. We said 52.5 degrees. And then you can say that the central angle here, the angle at the center, say the central angle will be equal to twice or 2 times the inscribed angle. So inscribed angle on the same arc. That's how you can put it there. You can always go and listen to the YouTube video. Okay, so this is 90 degrees here. And then this will be, the reason here will be the angle at the tangent. Okay, will form 90 degrees with the radius. All right, and then this angle that you have, we said is 52.5. Okay, and then, I mean, sorry, this is 90 degrees. And the reason for this is the angle in a semicircle, half of a circle. Are you following? So we've answered everything on that first page. I don't know whether to continue. Okay, so all those questions that we've answered, what did you get for this one? We said this one was 52.5. Here you just had to calculate them. This one is 75 and this is 37.5. Confirm with your answers there. Okay, so we've got all of that. All right, so we move on. All right, guys, those of you that did not answer the question, those of you that did not answer the questions, I can't answer every question for you. So we go to the questions that were highlighted under the same one. So we're going towards the trigonometry questions now. This one was not highlighted. So Guvi was asking a little bit on graphs in practical situations. Guys, this is just physics. Motion, eh?
Yeah.
So it depends on what you are given.
Yeah.
If you have the distance and time graph, that means that the gradient here will represent the speed. Are you following? So the gradient is always change in y over change in x. So if it say find the speed of the train from 7 o'clock to 7:30, from 7 to 7:30 here. So what is my change in my y over the change in my x? My change in my y is equal to 50 kilometers and my change here will be 30 minutes. Are you following? From 7 to 7:30. So 55 over 3 kilometers per hour. That's fine. Eh? Are you following, guys?
Yes,
Okay,
sir.
so the
Yes,
other
sir.
problem that I have, the other problem that we have here is we need to put it in kilometers per hour. Are we following? So the time here that they gave us here, they should actually put it here that it's in hours, ne? They must put it in hours because it's 30 minutes, 10 minutes, and so on. So they might have it in minutes over here. Okay, so you have to change the answer that you get here, because the answer that you get here will be in minutes. Ne? So kilometers in minutes, if you put it that way, because it's half. By the way, you can actually put it as half an hour. Yeah, so if it's 30 minutes, instead of putting the 30 there, I will say change in Y over change in X will now be the change, which is 50 over 0.5. So that will be in kilometers. This will now be in hours, because 30 minutes is half an hour. Okay, because they want you to put it in half an hour. What is the average speed of the whole journey?
Yes, sir.
And then you will put it as, just hold on a little bit.
Sir. Can you, sir?
Okay, so here, let's go on. This will be 100 kilometers per hour. Average speed will be the total.
Yes, sir.
Basically, the speed here will be the total distance over the total time. So the total distance that you will travel, you need to calculate what's the total distance. By looking at the graph, here the total distance is 200 kilometers, right? And the total time taken here is from 7 o'clock to 10 past 9. So that's 2 hours and 10 minutes.
10 minutes.
So you have to convert the 2 hour, 10 minutes to your hours only. Does that make sense? Are we together? Okay, so even if you calculate this in minutes, you can then okay, all right, guys. All right, listen, I don't want you to make the mistake now, whereby you think the total distance here will be the area under the graph. Are you following, guys? Here we are given the distance on the y-axis. So which means that up to here, he traveled only 50. And up to here, he traveled 150. So up to here, he traveled 200. So the distance is given there. Are you following? What if it was a speed time graph? Then the distance will be the area under the graph. Does it make sense?
Yes, sir.
Okay.
Yes.
So the total distance will be 100 kilometers. And then you have 2 hours and 10 minutes. So you should convert that 2 hours and 10 minutes there into hours.
It's 1/6 of an hour.
It's 1/6 of an hour.
Yes, sir.
2 hours
Basically,
is 130 minutes.
120 plus the 10 will give you 130 minutes. Divide that by 60 minutes will give you the amount of hours, which is what? 1.2.1.
2.1.
Divide that by 60.
2.1.
2.166. At least put it at least like
No.
that. 2.1666.
Oh, no.
So if you say 200, divide that by 2.16666, and then it will give you 92. No, don't round it off. Don't do the premature rounding, guys. Only round off your final answer. At least give it to 4 decimal places or so on. So then your final answer should be 92.3 kilometers per hour. Are you following, guys?
Yeah.
So 92.5.
Pardon?
Yes, sir.
92.5, sir.
92.5. You are doing a premature rounding, guys, because now you are saying 2.2, then it will give you your 90. Imagine if you already say 200 divide by 2.2, for example. This answer will give you 90.1, which is not the same as this. That's why I'm saying you're premature rounding. At least in your calculations, keep 4 to 5 decimal places if it's not exact. Preferably the whole display of the calculator.
2 and 1/6, you also get 92.3.
Yes, because 2 and 1/6 there as a decimal, I mean, as a mixed number is more accurate.
Yes, sir.
Does that make sense? Yeah. So if you say
Yes, sir.
200 divide by 2 and 1/6, then you should get the same answer. So premature rounding, guys, is dangerous. Né? Okay, so let's move
Very
on. Louis, I
dangerous.
think you get a hang of this. Né? So in this case, we've got a speed time graph. So that means the distance under the, the distance will be the area under the graph. Are you following? So for you
Yes,
to
sir.
find V, they want you to calculate speed. So you'll take the distance, divide that by the time it took for that distance. Are you following?
Yes, sir.
Okay, so the V here. So you must find out what was it. So find the V. How will you find the V? They say for the first 30 minutes. Okay. So the maximum speed will be at V. So it will be how much distance did you cover? And then over the time. I think this one we can also skip. Ne? I'm rushing for time now. Let's see the questions that were asked. Ne? We must have some questions from you. That was now on trigonometry. Okay, hold on.
It's the type shit.
Which one was it?
Are we going on a break, sir? Like shortly?
Yeah, we'll go on a break after this one. Was it this question? Okay, guys. So there was a question on this one, and then all right, let's quickly look at this before we go on the break.
So we'll just
Okay.
click onto that page.
So the diagram shows the front view of a house. So you've got the triangle up there, and then the rectangle there, and the height is given there. So the height is just from S to R. That is only for the rectangle. And then we do not have this part from here all the way up to here. We don't have, but we can calculate that by using your trig ratios. So you can apply trigonometry there. That is fine. Okay. So what is the height of P above the ground level? Now look here, guys. Where is my ground level? My ground level down here is here, right? So they want to know what is the height from the ground level all the way up to P. But what is good about this here is that this section, now I'm writing so
Is
funny.
3.4 meters.
Ooh, I can't make that only to this side. Nah? This section is 3.4. So the only unknown is from here all the way up to there. That is the unknown. So applying Pythagoras there will be so, ka, twa. Are you following? All right, this is my focus angle. So this is my opposite. The other given part is my hypotenuse. So I'll apply sine. Yeah? So the sine of that will be opposite over the hypotenuse. So if you do everything correctly there, then you'll say sine of 50 degrees will now be the opposite, which is unknown. And then your hypotenuse is 4.8. So multiply both sides by 4.8. 4.8, this cancels. So that part now will now be 4.8 sine of 50 degrees. If you punch that in your calculator, you will get that as 3.67 plus then the 3.4 to get everything from ground level. So that will give you 7.08. Okay, I think that part is fine. All right. And then they want PR. So where's PR? We want this one here. Okay. So the good thing about this is you can still apply Pythagoras again. Eh? Okay, so we want to go from here, from P to R. We want that length. Now remember, this one you have just calculated, nah? And then you say that one was 3.67. Are you following, guys?
Yes, sir.
Okay. All right. What else do we have that we can fill up here?
Sir,
Okay. So we should first, yes.
is it not supposed to be 3.68, sir?
3.68.
Because
Okay, let me.
No.
So I just worked it out. It should be 3.68.
Yeah, it should
Okay, let me just double check.
Round
Let
off.
me just
Yes,
double
sir.
check on my calculator. Yes, it
True,
should be
sir.
3.68. Thank you for that. It should be 3.68. Would make this now 9.
All of us goes outside.
No, sir.
7.
Let's
Sorry,
cast
it should
outside.
be 0.8. Yeah?
Yes.
Are you agree? Okay.
Yes,
So now the problem that I have here is, look, guys, this whole length, and that's how you need to use what you are given to find out or to get the unknown one. So you are given this whole length of ST, which is equal to 9.6. But we can apply Pythagoras here to find this piece here. Because the aim here is to use, to find that one, we must use this triangle. The only thing we have on that triangle is only this side, which is the 3 point, and then we need to correct that one. 6.8. All right, so we only have one side, but if we get this bottom part here, we can apply Pythagoras because that 90, this must also then be 90. So get this one first, take that length and say 9.6 minus that length will then give you that one. Once you have this and that, you then say that squared plus that square root of everything must give you your PR. Are you following, guys?
Yes, sir. So basically we should use
7.5 if you do it correctly, nah? Or with my wrong answer, I'm not sure whether that's the case. Okay. So if I say 3 point, let me just punch it in 6.8, nah? So 6.8 all squared plus then what was the other one? 3.4 all squared should give me I needed to add them together, nah? Okay.
No.
Sorry.
Subtract.
Yeah. If I subtract, then I get 6.5. Okay. Okay. So what do I get then? My answer it will still be 7.5.
So what are you basically doing? Are you adding P and R?
Look here, guys. This one here. What did you get for this length here?
Which one? This one, yes, 8.
What did you get for that?
3.1.
3.1. So if that is 3.1, then you say 9.6. 9.6 minus 3.1. That gives you this length as 6.5.
Yes.
Okay, now let's focus on this triangle. So we're focusing on this triangle. Now remember, we are having this side as 3.68. So if we focus on this triangle, remember this is also 90. Sorry. That means 6.5 squared, that side, plus your 3.68 being squared, square root the answer. Does that make sense? That gives me about 46943.
Yes, sir.
Rounded off will give me about 7.47. If I put it to three significant figures. Yes, so the answer is 7.47. Are you following, guys? Oh, sorry, not that one, this one here. Okay, so there was another question. Oh, okay, there's something else. I want us to, okay, there's another question again on the trick as well. All right, what I want you to do is, you see this question, that is what we'll look at last. Okay, and then we'll also look at the graph of your cast diagrams, how to find the coordinates from this one. Are you following, guys?
Yes, sir.
The 7 and 8.
Yes.
Yes. But they are not with you. You don't have them. I just added them. Is that making sense?
Yes.
You don't have them. You don't have them with you, but it's something that I thought of that you can actually look at, because it's something whereby, one has to look into trick, because trick also has the cast diagram, but these are not questions that are very, very common. So because they are not common, it was only in about 2 papers, but the problem is it was in last year's paper, or the 2020 paper the grade 11 new papers. Remember, there were only 2 papers written, 2020 and 2021. So it was in, one question was in that paper, and I just want us to cover all parts, so that you understand how to answer these questions. One with this one, we'll do it last. 2020, I think it was paper 2. And then the other one was 2017 or something, where we had the graph. So 2017, paper 2 as well. So they are not very common. All right, but we'll look at them. Okay, so let us first look at the other question. of what you have on your paper. Where is that question now?
No break.
What happened to that question? Oh, this one. Okay, so the other one that I want you to look is 2017 paper 2. Okay.
Okay.
That one I shared it on soft copy. It's 2017 paper 2. Yeah. Okay. And then the other one is 2020. Okay. So just give me a second. Just a second. I'm just quickly adjusting something here.
So do we have this paper, sir?
No, you don't have that question. Jambos, you don't have any papers.
So it's Herald,
never
sir.
came to. How did you do? Did you copy them or what?
Sir, it's Herald.
Oh, is it Harold? I thought it was Jambos.
So we don't have this question.
Yes, you don't have it. It's something I added later on.
So we
But
do have it.
No, this one, the one that
So
is
we
being
do
displayed,
have
you
it.
have.
It's on the back of the page that you just read down.
Okay.
Oh, we do, sir.
Check the back of the page that's it.
Yes.
Okay, just a second, guys.
What's up, guys?
Hey, Danny.
How are you doing?
I'm okay.
I'm doing fine. Is it raining right now in the city?
Not where I am.
All the fast cars outside.
I need to put my rain cup. You know I have a rain cup, right? So every time.
Okay, guys. All right, Danny boy, please calm down. Okay. So what do we have here? This is three-dimensional vectors, now. Vectors in 3D. Okay. So let's look at this together. So they are saying that the diagram shows a vertical pole, which is your HL. Okay, so basically the vertical pole is your HL over here. Okay, which is 20 meters. Guys, somebody's making noise there. Okay, thank you. All right, so now because it's the vertical length, let me just take this triangle like this. So it's as if it's flat against the wall, right? Because what happens here is this thing that shows you with the dots here shows you that it's going into the page, né? Or it could even be upright going to the north. So having this angle and that side, you can find out that side or you can find out that side because you can use your SOHCAHTOA. So this will then be your opposite and then this will be your adjacent and this will be your hypotenuse. So you can apply that to find any of that if they ask you for that. All right. Are we together, guys? All right. Okay. Now let's look at another combination. Without looking at the question, I'm just giving you some hints. Now look at this triangle here.
Sir?
Looks like this one might be flat.
It's an
on the ground.
isosceles triangle. Means that
Yes.
this one and this one both be 6.8.
So my paper 3, my set of papers doesn't have this page because I've been looking through the whole paper. It doesn't have this page.
But the rest of you have it. Maybe it might have just missed it
Behind the
somewhere,
last
but
page.
at least that's just focus on the question then. All right. Now,
Okay,
since they
thank
are
you.
telling us that this A, L, and LB are the same, that means this side must also be 6.8. And then you've got
Yes,
an
sir.
included angle. So which means
The
which law will we apply?
Right.
Guys, which law are we
It
applying?
would be the cos rule.
The cosine rule.
The cosine rule.
Because what they are asking is they're asking us to find this length here. They're asking for
Of
that
A
length.
and B.
Yes. So what you can now do is you can use what you are given in the triangle to label your sides. Nah? So one could then easily say that if this is 6.6 and this is angle L, then this will be L. Are we together? That's one way of looking at it. But if you remember your cosine rule, the other way around, you can then label your things as your A, B, C, and so on. Okay?
Also use a sine rule.
Okay.
Break time.
All right, sorry
Breakdown.
guys, sorry. All right, let's go back to this. Wait, let's just clarify this. I was just quickly checking something here. This side is not 6.8. Did they tell us that this side is 6.8? Let's read it carefully, nah? I think I heard someone saying it's an isosceles triangle, so I assume they. So let's be careful there, nah? I think that side you should get it from the Pythagoras first. The trig, not Pythagoras, but trig ratios rather. Are you following, guys?
Yes, sir.
Okay, so in order for me to get this length here, look here, let's get this length here. So what am I going to do? I'm going to use this length, which is the 20, and I'm going to use this angle. So labeling that will make this opposite, and this is my adjacent. Opposite and adjacent is 10. So 10, 77.4 must be equal to the opposite over the adjacent, which is my LB. So I'm looking for side LB. Okay, making LB the subject of the formula, we can easily just get rid of the fraction by multiplying each side by LB. This will cancel. So I'll finally have LB 10 of 77.4 is equal to 20. So I will then divide both sides by 10, 77.4. Do the same on this side to keep the equality. This and this cancels. Then my LB will be equal to 20 over my 10, 77.4, and then
So
let's
that's
punch them on the
4.47.
calculator.
4.47. 4.47, sir.
Jen me, bro. Exactly.
How much? Your Baba.
Say it's not working.
No.
Okay, all right, guys. So what did you get when you punch that in? You get
4.47.
Okay, good. But now,
4.47.
okay, perfect. So what I'm seeing now is you can use two things here, guys. You can go the long way as to what we have done and get the cosine rule, or we could also use the sine rule here, isn't it? Guys, look here, the sine rule, I've got a complete pair here. This with the angle, there's a complete pair. Does that make sense?
Yes, sir.
Okay, so I can use the sine rule straight away with this incomplete pair. And since I'm looking for the side, I will now say AB. Where is that? Oh, sorry, I'm looking for AB. So AB, let's use a darker color.
AB, sir.
That's AB.
We found LB Moses.
Ja, bro.
Dit was mos LB wat ons nou gekry het.
Ja.
LB, ja.
Ja. Kans kera Matisa.
You are that.
Okay, guys. You guys are invited to come and have each burger.
What?
A burger at Steers.
Dit was zo easy.
Jay, wat zeg Als je komt, je krijgt net man al.
Ela Danny J. Raskau. Danny J. Raskau, 6.
Button 9 plus
Otto, wat
9
is de
is
Maggi?
so it's going to be very mad at you.
Otto, wat is de Maggi?
Otto, wat kan aan je?
Nee, ik denk jullie kan niet zien hier.
Ik dom.
Oh, dat is dom, man.
Waar de papo.
Oh no, wat kan aan nu? Wat kan aan nu? Oh.
Die liga de legend op je podcast klikt. Oh.
Oh. David.
Oh, maar dit
Ja,
is dit, jongen.
David.
Ela fixa girasca. Sei o nele, não.
Exacto. Because he's standing by them.
Okay, guys, sorry. Hey, NG. So it's you who is writing on my board, huh?
NG.
NG, you must behave.
Yeah.
It's not Antonio. It was
Okay, let's
Antonio
go to
back
share
then. I
screen.
think you wrote now. Because my thing has
say
the
it was
annotation.
Antonio.
I can see who's writing on the board. Anyway, sorry guys. There was a little bit of an issue with my network. So I'm getting back to this, okay? So the first answer should be 9.59. Eh? If we apply the sine rule, you can go and confirm with the cosine rule. But it's always better to use
So we
what
can't
you are
see
given.
you, sir.
Pardon?
Sir, say again, it's
5.9.
Yes.
I can't see you, sir.
No, I'm coming back. Just give me a second.
Okay, sir. She didn't now.
Oh, Danny.
Okay. All right, guys.
Hey,
Hey, guys. Hey. Relax a bit, Danny boy, please. Okay.
Sure.
Okay, all right, guys. So that's 9.5. And then the next answer, the length of LB, if you work it out, it will be 4.47. So you can again use the sine rule for that one because you've got it. Okay, my bearing here is 180 degrees. Bearings, you always start from the north going clockwise and it must be three-figured. Né? Please understand that thing of the bearings. Okay, so now if you look at this one, because it's three-dimensional, guys, be careful, né? Because they're asking for, look here, they're asking for the bearing of, let me just get my pen right, bearing of A from L. So you always start from L. So let's go back to L and then we see. Okay.
There's no butter.
There's no butter. Né?
What?
Hey,
what?
Okay. So hey, sorry guys, sorry. So we're starting from L. So you need to draw a north line at L. Are you following? Okay. So you're starting. So you see the north line at L is given already to you. All right. And that means you have to get this angle over here. Are you following? Is that the right way of thinking?
Think nice.
Yeah, bossa. So the answer is 65.
Oh, nice. So let's just go a break.
Okay, guys, look here. So what I have here is coming to here and then coming to here. All right. So how will you then put it together?
180 minus 150.
Look here. So you are coming from L, that's the line that connects to this, right? So all the way up to here, that is a straight line. So that's why we say that this is 180. Does that make sense? Yo, Nancy is having an issue with the network. She's on and off and on and off. Okay, guys, stop there on the chat group there, please. Okay. the pop and the combo and everything. Then. Let's focus in the class. Okay. Okay. All right, guys. So now from here all the way up to that is 180 degrees. That's how we'll get that one. I think that's the last part of the question. Eh?
Yes, sir.
Isn't it 160?
Okay.
Sir.
180 because it's 180 is a straight line. So that is L. It's three-dimensional, by the way. Né? So you now need to start from that point and connect back to that line again that connects to A.
Yeah, I also just wanted to emphasize, you must not think that that line cuts the angle L in half. That's why you are getting 160 because you are assuming that the angle from N to the line B is 45 degrees. It's not. And another thing that you must also take note of there is the line is a straight line coming from A up to the north line. So because it's a straight line, you must remember the property of a straight line, which is 180 degrees. Did you get it?
Yes, ma'am.
Okay.
Okay. Guys, I think we've answered all the questions on that part, but now let me just take a break. Miss will just quickly finish the other cast diagram questions, how they can possibly ask them. So please pay attention, and then we will then take it after the break further. Or maybe let's take a break here.
Yes, sir. Yes, sir.
Yeah, let's take a break.
A break here.
Yes, sir.
Yes, sir. Yeah. Let's take a break.
Yes,
yeah.
sir. Ma'am,
And
just
then
do
you
the
guys
question,
can
ma'am,
even
please.
use.
Okay, guys, let's just finish this question, then we are done with part 3. So when we come back, we can just look at questions on part 1 and 2 because we have answered everything.
Okay.
I think transformation, sir. Transformation and vectors, we should still answer a thing or two from there before we move to part 2 and part 1.
Okay, let's quickly look at question 7. It says find the value of cos 123 degrees minus sine 223 degrees, giving your answer correct to 3 decimal places. So here you are going to use your calculator. Can you do that on your
Miss,
calculator?
on what page?
This on page.
No, it's not on the page. You don't have this. We just added it because it's those random questions. Yeah, so you can take screenshots
So
here.
then your calculator say cos 123 minus sine 223.
Hello?
So they want you to write it correct to 3 decimal places. So your answer will be 0.137.
7. Yeah, it's 0.137.
Yes. So you will have 0.137. Okay, and then the next question, they want you to solve for sin x is equal to negative 25. Now here, what you must think about is your cast diagram. So that negative basically means in which part of your cast diagram is sign negative. This A stands for all of them are positive here. In this second quadrant, it's only sign that's positive. In the third quadrant, it's only 10 that's positive. In the third quadrant, it's only cos that's positive. So now the moment they ask you a question like this, say 4 sine x is equal to negative 25 degrees. They are basically asking you in which 2 quadrants is sign negative. Can you guys tell me which quadrant is it? This is your
In the
first,
quadrant.
your second, your third, and your fourth. So in which 2 quadrants is sign negative?
In the third and the fourth one.
In the third and the fourth. And then what you must also know, what you must also take note of is
at the 4. Yeah.
Whatever angle you get in the first quadrant, the answer that you get, that is the angle that you are going to use. That's our reference angle. And then in the second quadrant, whatever angle we get, our reference angle will say 180. minus our reference angle. In the third quadrant, we'll say 180 plus our reference angle. In the fourth quadrant, we'll say 360 minus our reference angle. Let's say, for example, our reference angle is 60 degrees. So in the first quadrant, it will remain 60 degrees because angles in the first quadrant are acute angles. So it's angles between 0 and 90 degrees. In your second quadrant, you are then going to say 180 minus 60, which will be 120 degrees. In the third quadrant, it will be 180 plus 60, which will give you 240 degrees. And you see that in the third quadrant, it's angles that range from 180 to 270. So 240 is within that range. And then in the last quadrant, we'll say 360 minus 60, which will give you 300 degrees. So that's where it belongs. But for this question now, we are given 4 sine x is equal to negative 2.5. We are going to ignore the negative. The negative is just there to guide us as to which quadrant it belongs to the answer. Yes. So what we are going to say now is to say 4 sine x is equal to 2.5. I'm ignoring the negative when I'm solving. Then I divide both sides by 4. And then the 4 will cancel because I want to find the angle x. And then the next thing I'll do is to say angle x will be equal to sine inverse of 2.5 over 4. What do you get?
36.8698976.
Miss, how do you put your calculator in degree mode again?
You go to the mode,
Mm-hmm.
and then you choose the DEG, the number that's representing the DEG.
Or press the
Miss,
restart button
mine
at
is
the
not
back.
having. Oh, mine
Okay, I'll show
doesn't.
you.
Mine because
I'll show
I
you
lost my
tomorrow.
calculator.
I'll show you tomorrow at school, Danny.
Are you using the sharp calculator, Daddy?
I'm even having the sharp one by me, sir, and I lost
Press
mine
the
in class.
reset button. Press the reset
back.
button at the back.
With a pen, or a pencil.
Okay, the reset button.
Miss?
Okay. I
It looks like
pressed
a
it.
little hole. Yes, then it should
Yeah, I
be in
pressed
degree
it.
mode.
Then it's fine.
Does it say D, E,
Now it's
G
in
at the
degree
top?
mode. Oh, now I
Yeah.
just do. Yeah.
Okay,
and now
that's
it's in
good,
degree
Danny.
mode. What do I do? Just second and yeah,
Second
and then
function,
and then
yeah.
I'm in it. Yeah.
Okay, good.
Yeah.
Okay,
Good.
did you guys get 38.7 degrees?
Yes,
Yes,
ma'am.
Yes, ma'am.
Okay, now that we have our 38.7 degrees, it's our reference angle.
Yeah.
Okay, but now it's just in the first quadrant, but because of this negative, our answer belongs to the third and the fourth quadrant. What is the formula in the third quadrant?
180.
300.
180. 180
Yeah.
plus the reference
Plus
angle. Plus the reference angle. So now what we are going to say is to get our first x, we are going to say 180 plus the 38.7. Okay.
Yeah.
And you get
What do you get?
218 plus 0.7.
208.7.
So it's 218.7 degrees. That is our first angle. Our second angle will then be 360 minus the 38.7.
And you
Yes.
get 321.3 degrees.
0.3. Now,
Ah.
sometimes with this question, here we are having our two values. Sometimes they can even limit you to say for the values of x ranging from 0 degrees to 270 degrees. So if they say that, then you only give this answer.
Okay, ma'am.
And if they say your value must range from 270 to 360, that
Then you
means
only
you are
put
only limited to the third quadrant, so you only give this answer. So it also depends on how the question is structured. Are we together?
Yes, ma'am.
Yes, miss.
Okay, good. So you'll get your 3 marks for doing that. So please don't
Okay.
use the negative when you're calculating this, okay?
Yes.
The negative is
Okay.
just to tell you which quadrant it belongs. Let's assume it was positive 2.5. That means you're going to use the first quadrant and the second quadrant, where your first answer was just going to be 38.7, and your second answer was going to be 180 minus 38.7.
Okay, thank you.
Okay, which was going to give you 141.3. So that is when this is 4 sine x is equal to positive 2.5. So if it's positive, then it belongs to the first two quadrants. If it's negative, it belongs to the third and the fourth quadrant.
Okay, ma'am.
Okay, let's go on to.
Oh, if it was a positive number, we would have calculated with the ones on top. And now we are calculating with the ones at the bottom because it's a negative sign. Okay.
Yes, so
our
that
answer is
cast diagram
correct.
there is very. Okay.
Okay, miss. Okay.
Okay. So the next question, in triangle ABC, AB is 15 centimeters, AC is 31 centimeters, angle BAC is 40 degrees, calculate the area. I think this one is straightforward. I wanted to look at the other diagram that Mr. Mugunda shared. This one you are going to use half this
times
the opposite side, so
31.
Small letter C, and this is angle A. So we are going to say half B C sine
times
A.
sin A.
Yes, so we are going to use this formula where in the place of A, we are going to replace it with 40 degrees. In the place of B, we are going to replace it with 31. In the place of C, we are going to replace it with 15. So it will be half 31 times 15 sine 40 degrees. Okay, so we go to the question 8. The diagram shows the graph of y is equal to cos x for the values ranging from 0 to 360. So that means, again, they are considering the whole cast diagram. The first question they are asking you is to write down the coordinates of Q at the point x is equal to negative 180. So the coordinate points is the usual. How would you identify coordinates? This will be your x value, and this will be your y value.
Y value, negative
So that's
1.
what you're going to fill in there.
180 and negative 1.
So it will be negative 1 and, sorry.
180. Because then you start with the x-axis.
180 and negative 1.
180 and negative 1.
Yes. And then the next one, find the value of cos 360.
One.
Cos 360 is 1. If you also look at your graph, you see that this 360, it goes up there until 1. You see that? So from the graph, you can also get it. Otherwise, you use your calculator. But looking at the graph, you can also get the answer.
Positive 1.
Yes, it's positive 1. Okay. For the values ranging from 0 to 360, find the two values of x for which cos x is equal to negative half. So what do we do here? Now you guys must guide me because I just did a question with you guys now. So remember your cast. And then remember here you say 360 minus your angle. Here you just take the angle. There you say 180 minus the angle. Here you say 180 plus the angle. So if they are saying our cos is negative, which two quadrants are you going to look at? This is your first,
the second and the third.
So you are going to look at the.
But for that question, do we need to use the cast diagram?
Yes, we are going to use the cast diagram because of this. Cos x is equal to negative half. So your two values again. So we are going to use the second and the third because that is where cos is negative. Okay. So then again, you will say angle x is equal to cos inverse of half, not negative half. Just say cos inverse of half. What do you get?
0.9999619.
No, cos inverse of positive half.
No, it's equal to
60.
60.
Yeah, it's 60 degrees. Okay, so now the next thing you are going to do, there are people making noise there. So the next thing we are going to do is to get our two reference angles. So how are we getting them? In the second quadrant, we say 180 minus the reference angle. What is our reference angle?
120.
60. Sorry.
60.
60.
So you say 180 minus 60, which will
get
give you
120.
120. And then you put 120 here. Or the other one, you say 180 plus the 60 degrees. Because that's the third quadrant. So 180 plus 60 gives you
240.
So those two are your answers.
No.
So whenever,
No, 180. Oh.
so whenever you see a question like this, you must remember your class diagram. Okay. So are we fine with the class diagram?
Yes, ma'am.
Okay, thank you.
Guys, listen. The reason why I added that, listen, guys, the reason why I added that is because the other questions doesn't have it, nah? But anyhow, listen, we're going to take a 30-minute break. So that means 7:15, we must be back. Same, what is this thing called? Same link, everything. You know what we'll do? We're not going to stop the meeting. We are just going to what is this? Leave it on so you can leave and then you can come back again after this. Are you following, guys?
Yes.
All right, so we're just going to use the same link. All right, so let's take a 30-minute break. And listen, when we come back, we're going to look at statistics and probability part, because they are always in the papers, as well as graphs of functions, and then we can take it from there. At least I want to cover those
some
two.
algebra, sir. Some algebra.
Yeah, we will get to that. But we start with stats and probabilities, and then we take it from there. Okay.
What time are we coming back?
Yeah.
Okay, bye guys. Go and eat something.
Yeah,
So what time are we coming back?
We'll be back soon.
Yeah.
So what time? So what time?
Yes, said 7:15. 7:15. Eh?
Oh.
No, said no, the first class
No.
outside you.
Wens gaan nie julle mobile. Gaan nie eet or Jy van praat.
Ja, julle is
Move the wins. Move right.
Ah, waar is maar julle praat baie.
Oh, mes chop zaman more. Asia. You never give.
Never give me.
Gaan. Break. Ja, is break.
All the Feskers outside. That's how.
Oh my God, the best guys outside.
Hey, Ras.
Oh my God, can't wait to see Cek, ini nggak aku ngomong. Given, ini apa? Moses, come here. You just must come clean your mess. Kan Moses ini. Ini coisa aí, tá me tomar pona. Isso coisa aí. Ini Moses.
Sometimes in life.
Let's check. Terus si traf mensen. Waarom is dat? Het is klinken als braaf. Kama animal pagi kama wafamen wabagota de. Kenapa bisa klapas uap? Yela cara está nos uap pra no difficult net na.
Just go put the phone down there.
I made for you bread too.
It's fine. Huh? I'm always asking you for things, then you don't want, but then if you ask me for your projects and stuff like that, then I put your food. Maybe I'm not married with you. Mama, I want to
Can you put the phone?
Did I answer the project? I'm going to say.
Project activate. Oh, pola niya kita pereka.
Can you mute yourself?
Pereka mawada si perekan. Wait, kau isang macam kamu.
Cik, ai.
Come on, at least 5 more. To the options, back to the east side, go to the east side, go. God, I'm about to shoot up your body, cause that's what I feel like. If I don't pull up and come here, I don't feel right.
All the fast cars outside. Danny boy.
I did it, never hate it. Never hate it. Did a lot, but I never hate it. We throw the money up. We throw the money up. I did a lot, but I never hate it. We throw the money up. We throw the money up. Strap on my drivers. You know it's no running up. You go get the. I'm tearing Fendi down. I'm hot, that's a Fendi now. Jacket say Fendi now. Won't pay for no verses. I'm smoking the black. Was they mad at pie? I ain't have a grip, but I had a better stop. Remember, I was trying to caddy cop. In and out the back of paddy wagons. Pockets probably pack a lot of salad. Dap it out. They reach out their hands trying to dap it out. I go in my zone and I got my boarding pass. I just want all the.
Are we starting, sir?
Starting. Hello, guys. We're starting now. Danny boy, put your music. Danny. please, Danny, if you keep shouting and so on, we will keep you on mute forever, nah? So please, some of us are using headsets, Danny. So if you shout, then it's not good for our ears,
Yes.
man. Please.
Yes, sorry, sir.
Okay. All right, guys. So those of you that are chatting on the sideline, please stop chatting on the sideline. Eh? Movita is no what is it? No Morvita and Pap. What is a Movita?
Movite.
What is the Movite or what?
Yeah.
Kenny and Movite.
I'm having a problem, sir.
You're having a problem with what?
I thought my screen was a bit confusing.
So
I'll be with you now. Just give me a second. Let me just set up. Guys, I gave you graphs.
Excuse me, sir.
so you're muted.
What? Let's just a good change.
Alright.
Hey, man, it's not no deep, man, here. Deep. Even my laptop, is up. Oh, I is 100%. Yeah. Who said? What?
They need to keep quiet.
Oh, sorry.
Let me talk to you.
Outside. Be quiet.
Then you're the only one talking, please.
Simon said.
Just for you.
Yo, but my thing is too loud, man. I think my speaker is near the laptop, too loud. That's why it's making noise. Can you guys see I'm talking soft?
Reset is so playstyle as a improve.
Nick, you've gone JJ.
Yeah, my JJ. That's a of AJF. Of A. That is your story, young. Hey, young.
Can you alsjeblieft praat net sagter?
Okay, guys, let's keep quiet.
Ella.
Let me talk more sister. Jimmy, I have
It's just preparing stuff. Just be patient. Okay.
Jy kan jy iets maar. Om goed die papiere hier so.
If I can talk to me.
Ella Harris, die ras ook al asseblief toch. Veel net maar.
Ja, die ras.
Okay, guys, sorry. I was just sorting out my network. I'm back. So listen, we're going to go over to plotting of graphs. I'm not going to plot a graph. I'm going to explain the concept of how to do it, because plotting a graph is something that you need to exercise. Né? It's something you need to practice. All right, so let me go there again, guys. I want you to stop putting anything that is not related to what is this, the class in the chat box. let's start and let's try to make the best out of this limited time for revision that we have. Okay, so
Sir.
I'm going
Yes,
to
sir.
go back and then I want to start with this. Guys, listen, you do not have
Is
this.
this still paper 3, sir?
Yeah, no. This you don't have, but it's amongst the soft copies I shared today, but you don't have it with you. So I want you to listen very, very carefully. Huh? Okay, guys, there are only 4 different kinds of graphs that you'll be expected to plot. All right. So all of them are here in their pictures. So this is a straight line graph. So this is the graph where you have y is equal to mx plus c. That's the general form of the graph, whereby the C is where is the x-axis been cut. So the value at where the x-axis is cut will be your C.
Doesn't that mean the y-axis?
Yeah, the y-axis, sorry, the y-intercept. So where the y-axis has been cut, that will be the value of your C. Thank you for that correction. And then you have a graph like this. Now this graph will have a constant. Now we'll just use a 1 for now. And it will be having a variable at the bottom. Now, guys, this constant, you are not limited to 1. It could be 3, it could be 3 over x, it could be 4 over x, whatever the case is. Are we together? The only thing you need to understand here is when it's a -1, then it will be in your second quadrant and in your fourth quadrant. That's when you are having a -1. If it's a +1, then you will have it in your first quadrant and in your third quadrant. Okay, so which means it is 1 over a positive x if it's 1 over a negative x. Are we together? Now the value that you have on top, if it's 1 or 2 or 3, just changes in terms of the shape of the graph. Are we following? Like, is it getting a bit wider or is it getting a bit narrower? That's the only thing that it does. Okay, are we following, guys? So that's the one form of graph where you have a constant over the x. And of course, the parabola that we have here, we know. So if it is anything raised to the power of 2, then we know we've got a parabola. So based on a positive or a negative. So here it's a negative, a sad face. If it's a positive, it will be a smiley face. And then the final graph is when you have a constant over a quadratic. Are you following? So when it's positive, it will be in the first and in the second quadrant. Just like the +1 being up there, these two are also up there. So it's almost like just the x squared, but it's just over a constant. Again, this constant can be anything. It could be 3 over x squared, for example. So it will just determine whether the graph is narrower or whether the graph is more approaching the asymptote in that regard. Does it make sense? Okay, so now to recap, we said only 4 graphs, all right? So let's look at the question. The question says we must relate the equations to either figure 1, figure 2, or figure 3 or 4. So let's look at the first one. This is a linear graph. So obviously this will be which figure?
Figure 3.
Figure 1. Yes, figure 1, okay? Because it's a linear one. This is basically where we are saying y is equal to mx plus c.
mx plus c.
Yes, so your m here is a -1, negative gradient. Are we following? So this will now be for figure 1. What about this one? This is to the power of 2. So which figure will it be? It's only between 2, 3, and 4.
Will be a positive.
3.
It should be figure 3. Perfect. Okay.
Yes.
All right, Fidel, your hand is up.
So I wanted to ask, do you have this paper?
No, you don't have it. You have the soft copy of the paper. It's something I added today. Okay?
Oh, okay.
So this will be figure 3. What about this one? Remember, it's a constant over that and it's negative. So it's just between figure 2 and figure 4. Which one will it be?
I think it's figure 2, sir.
It's going to be figure 2. Perfect. All right. And then let's say the other one is not here now. So if we had this one, it would have maybe be y over x.
I can't see on my screen, sir.
Does that make sense? You are saying what, Danny boy?
my screen, sir, it's not showing like when you're explaining, sir.
It's your network there, man. I think it's not
It's
coming.
my net,
Okay.
but the Wi-Fi is by me, sir.
Okay. All right, guys. So the final answer will then be figure 2. So it is figure 1, figure 3, and figure 2. That's just the general one. Okay. Now let's go to, I think the graphs were in our part 2, isn't it? Or where were the graphs? No, graphs and functions. Oh, sorry, guys. Okay, let me go back to part 3. Okay, so we are still doing part 3, so we're actually concluding part 3. So let's go to graphs and functions. Sorry that I'm scrolling so fast.
Please check maybe the problem, because it's deep, sir.
It's just you.
No, it's only you that's having the problem. Even if the Wi-Fi is with you, it doesn't mean that if it's sitting in your room, it's fast enough. It's about the reception that it gets.
Okay, sir.
Okay.
Let me just.
Okay, guys, now listen very
As I
carefully.
exit, as I leave, sir, I don't know.
No, it's fine. Does anyone else have a problem? Do you all see the screen?
Yes, sir.
Yes, sir.
Yeah,
but it only shows the graph, sir.
Yes, that's where we are.
Okay.
Okay, guys. Now look at this graph. What is it? A constant over x squared. So what does it look like?
Sir, it is gone, sir, because it doesn't show anything. You are not doing anything on the screen.
Then you go out and come back again, because nobody else has the same problem.
Okay, sir, please check for me that I come in.
Yeah, no problem.
Thank you. Okay, sir.
Okay, guys. So what do we have here? So we've got a graph that would look something like this. Are you agreeing?
Yes, sir.
And this where you have this, that's where the break is. Whenever you see this colored or shaded area, that's where the break is, okay? And you can clearly see that my X here are all negative on this side, and my X here are all positive on that side, and it's symmetrical. It's a -2 and +2. It's a -1.5, 1.5, and a +1.5, -1 and 1, and -0.5 and a +0.5. So again, for you to plug in your SUT or even the TUS on this side, because they will be the same values, what you need to do is to plug it into your calculator. So let's just try that on your calculator. Okay. So what are you going to do? Just plug in on your calculator. So you're going to press the fraction sign. Once you press the fraction sign, then you will say, let's say, for example, this is the fraction sign, okay? So then you'll put in your 3, and then here put brackets, and then you just square it already. So that, for example, this, you would just come and put a -1.5, and then
it's a 1 1/3.
Okay. So 1 1/3 should be 3/2. Okay.
No,
and then
so it's 4/2.
Over 2, sir.
4/3, sorry. 4/3.
Okay. Oh, sorry. I thought 1.5. Okay, 4/3. So you can put it as decimals, and you only put it to 1 decimal place for all of that. Listen, guys, I'm not going to plot the graph. I'm giving you pointers here now. So what I am trying to tell you here is the following. Yes.
So can you quickly re-explain the part about how you got 4/3?
Okay, let's quickly go back there again. On your calculator, press the fraction button.
Okay.
Did you press the fraction button?
Yes, sir.
I want you to press the following on your calculator. I need some space here.
Of the video.
Okay, so it is 3 over open brackets and you square. So this part of this, that's where you put your X value in. That you are given on top. Does it make sense, Brendan? So here are your X values. So you will now put in -1/2. I mean -1.5. So you will say, you take the equation here and you say 3 over 1.5 negative, and you square that. Then that should give you, then you give me the,
decimal
of that. Give me the decimal of that.
1.333 and then it goes on.
1.33333.
So we can put
Wait,
it
what
as
is this, guys?
1.3 because Danny, just find the thing there, guys, please, Danny. That we are in part 3, graphs of functions. So we are graphing the functions, okay? All right. So
Okay.
now in this case, then it will be 1.3. You do the same thing. The reason why I'm saying put 3 open brackets and squares so that you are able to change this. So instead now you put a -1 in there, which means this answer will just be 3. I mean, sorry, it will not be 3 because it will be, yeah, it will be 3, correct. All right. And then you come and put in your -0.5 again. The value that you get there would be for you. You repeat the same thing for all the others here. Your X values will be the ones that are given.
U is 3 and T is 12.
Yeah,
It's
okay,
12.
so this will then be U is 3 and T is 12.
Yes.
Okay, good.
Yes, sir.
Yes, so yes.
No,
I'm
sir,
not too
the U and the
listen,
three
guys,
on the
listen.
Off.
Okay, guys, please. I don't want you to focus on what I'm putting. I want you to understand the concept. So if we put U is I mean T is U, this is 12, U is 3, and then this was 1.333. Guys, listen. Please understand the concept, because if I have to plot this graph and put every answer, we will spend at least 20 minutes on this question alone. So therefore, I'm really just want to show you the concepts. There's a difference between coming back and plotting this graph. So if you can understand the concept, make sure that ask the questions on the concept. How do I put it? How did you get this? Where did it come from? Then it's fine, because I can plot this graph. We take 30 minutes on it, and then we'll not be able to do statistics and probabilities and so on. I want to show you, because you know what I did? I gave you these questions, not this particular one that I gave you yesterday. I gave you these questions during recess week. And then you were supposed to plot these graphs already. I gave it to you as homework. By this time, we will just sit and just answer the questions. You understand? So you had this beforehand. All right. So now if we know how to put it, like for example, Brendan asked, how do you get this? So if you know how to get the first one, you apply the same concept for the second and for the third one. I'm just doing it for the sake of time. All right. So question A is perfect. B, now this is again another skill. Here you need to read carefully, okay? So use a scale of 2 centimeters to represent 0.5 units, okay? So you need to come and take your ruler, and let's say, for example, you use your scale. For example, you are using your scale. That means if this is 2 centimeters, that means each of those 2 centimeters there in reality should represent 0.5. So if you are starting at 0, it should represent, so the next 2 centimeters should then be 1. The next one would be 1.5. The same to the negative side. This will now be negative 0.5, and it will go on. So you'll also need to know how to get the intervals to get to that side. That is what this first part represents in terms of the units that you'll use for that. But not only do they give you the units, they also give you the range. First of all, they say that this is what is going to be represented on the x-axis, and then for 1 centimeter to represent 1 unit on the y-axis. So it's different. So you change around to the y-axis. Then you say that if I measure 1 centimeter, 1 centimeter represents 1 unit. So every centimeter will represent a unit. That part is fine. So the first part of that will just show you how to get the intervals. Then you get the range. But Miss wants to add something here.
Yeah, I also just wanted to emphasize that there where they are saying using 2 centimeters to represent 0.5, you must also study the figures in your table. Now, if I look at my table, it's ranging from -2 to +2. So because there is a balance between my values there, my 0 will be in the middle. But there are times that your X values may be just has a -1, -0.5, and the rest of the values are the positive side. So the way you arrange your values on the table also play a very big role on the graph. You must study your teacher.
Yes, ma'am. You have
Okay.
to plan it properly.
Exactly. That is a very, very important point. So what we're trying to say on that point, guys, is the following. Brendan, you're making noise, man. Brendan, there's background noise there.
Sorry, sir.
Thank you. So now, in this case, guys, look, after you have your scaling correct, that's one part of it.
Can you hear us, sir?
Can you hear you, sir?
Can hear you.
Oh, you can hear.
Mungunda.
Wow.
Hello.
So we cannot hear you.
No, we can't hear.
Christmas, man. Oh.
No, you said when the 2-piece mask. That's a 1-piece. It's stretchy like the others.
Yeah.
Ah.
Like is the host. Wacht eerst,
Mikey Hick.
Mikey
Hick. Mikey
Oh,
Hick.
Dexa.
Ja, voor die naar Joey.
Oh, maar put you also key.
You can put your blame auto the camera.
Combo.
Bra, dit is niet jaloers. Oh.
Moet karas maken.
That's alright, put yours. Weet je, is kaas de camera.
Ya como que mobile de mi se wifi go.
Yeah.
Mr. Mungunda, as je weer in klas zit, tekst hem gewoon daar zo op de groep.
Anu Antonio, die daar niet zelf met je mond praat, joh.
Wat zeg je?
Malestel.
Hey, Danny, als je praat, dan trap meneer zijn wifi. Blijf stil.
Okay, sorry guys.
Resource Mr. Mungunda is terug.
Yeah, so the ones that said Danny, als je praat, dan maakt die wifi zo. Okay. Okay, guys, so let's go back to this. All right. So as I was saying, that thing which is written, okay, let's just get the screen to share. This that is written in an inequality form, yeah? It says that from here up to here, that's what I need to plot on my x-axis. And then they were supposed to do the same thing for the y-axis. Are we following?
Yes,
After
sir.
you have plotted the graph, listen, because this graph, generally, it is supposed to be something that looks like this. So let's say for argument's sake, so I put my, sorry, I think here for the graphs, we need to make this thing a little bit thicker, especially if we are trying to put across the axis, maybe a little more than that. Okay, so let's say I put my axis there, and then I say that this is my 0, that is my 0, and then I say, okay, it ranges, say from, this is now where we're doing 2 centimeters, okay, so it ranges anything from -1, -2, and then let's say this is 1, and this is going to be 2. So then I look at my y, but you see on my y, I only have positive values. So I can just strictly focus on the top part only, even if I draw and show like that, all right? So now I will just say that every centimeter now, so this is going to be 1, this is going to be 2, this is going to be 3, and this is going to be 4. But now look at my y, it only goes from 0.8 up to 0.8 on both sides. Are we following? But you remember, some way my t and my u, there was a 12 as well. Are you following? So now if I put my graph like this, and I put my graph 5 and 6, what happened here? I ran out of space because I didn't plan properly. Do you understand? So this is what Miss was trying to say. Let me just get the values for my t. This was 1.33, and then this was 3, I think. Is that correct, Mia?
Yes, T is 12 and U is 3. Yes, sir.
And then S is 1.33.
Yes,
okay,
sir.
Okay. So now look at it, because you see, I was estimating this whole thing to be 1 and then this to be 2 centimeters. That was my estimation. That's why I make this 1 here. Are we together? But if you go and let's say, for example, this is what I have done in the exam, then it means my planning is not right. Does that make sense? Okay. But in your real papers, what's going to happen here on your real papers, if you go and draw this in reality, we know that the following applies. Okay. Let me just do this. All right. Okay. So every dark line that I have over here, let's say I put this, and this is now my maybe I should use the red color. Let's say, and this is now my x-axis. And then I said, I want to take it in the center, and then this is now my y-axis. So I drew it like that, okay? So now everyone here, I'm just assuming, because if I draw it like this as 1, 2, that's 2 centimeters, right? So that is -1. That's another 2 centimeters, that's -2. And that's another 2 centimeters, that's -3. In reality,
Yes,
this one will be 1 centimeter, okay? And then this one will again be 1. And then this, every 2 centimeters, sorry. So we'll not take that 1, and this will be 2. Maybe I can have an extra. Okay. So every 2 centimeters is 0.5. Okay. Mercy is quickly correcting us over there. I'm not sure. What does the graph say there on top? You have the paper in front of you, isn't it?
Yes, sir.
Yes, sir. It says 1 unit on the y-axis is represented by 1 centimeter. And every 2 centimeters represents 0.5 units on the x-axis.
Every 2 centimeters represents 0.5. Okay, perfect. So
Yes,
in that case, then we will have every 2 centimeters. So this is 1 centimeter. This will be 2 centimeters, 0.5. This will be 1, and this will be 1.5, and this will be 2. This will now be -0.5. Mercy is now forcing me to draw this thing, which I don't want to do, but yeah, let me do it. -1.5, and then this will now be -2 here. So these are my intervals that I have. And then every 1 centimeter here, 1, 2, and then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 12 was the highest. Are you following? So 1, 2, 3, 4, 5. Guys, we'll go until 12 o'clock. That's what I'm trying to avoid here with my wife, but she wants me to plot every
no
graph.
problem, sir.
Okay.
No problem,
all
sir.
different. All of them are different. I would rather want to plot the straight lines, but all 4 of them are here. All right. So what will you do now? What you're going to do is this pair, which is -2 for x and y is 0.8. So you will come. So basically, this is your y-axis and this is your x-axis. So you come and get your 0.2, 2 and 0.8. So this is your 2. Let's use a different color for your x and 0.8. So each one of this, now I need to zoom in. Each interval here is 0. This one will be 0.2, 0.4, 0.6, 0.8, and then 1. Does that make sense? So basically, what's going to happen here is, remember the point we are plotting here is going to be x is -2 and y is going to be 0.8. So it's going to be at 0.8 and 2. So this will be the point over here. Does that make sense?
Yes, sir.
Okay. What's the next point?
The next point is -1.5 and 1.33, I think so.
Okay,
Like
so it will be -1.5 is here, and then 1.33 would now be. Now you need to estimate, because this is going to be 0.2. Okay?
Yes, sir.
This is going to be 0.4. So -1.3 will be somewhere in between that, but more to this side here. All right, so it will be something around here. But at the end of the day, guys, at the end of the day, this is what your graph would look like at the end of the day. And then on the other side, exactly the same thing that looks like this. Is that making sense? Okay, so now that you've drawn your graph, you'll then get these 3 points you'll get from there, and then 5 marks for that. That's already 8 marks, guys. Are we following?
Yeah. Oh, just
Okay.
8 marks, just like that. Oh.
Yes, so you'll get 1 mark for plotting. You 2 marks
Sir.
for the 2 curves, and then
Sir.
you'll get maybe another 2 marks for your scaling, or maybe 1 mark for scaling. And then another one for labeling your X and your Y and your numbers. Okay.
Sir. Sorry, sir. I just wanted to quickly. Sir, it's just quick. I just want to know, how do you calculate those ones again to get 1.3, 12, and 3? You Y.
Okay, so now you can label here on the graph here as Y is equal to 3x squared, so that we see that.
Yeah, so you know it's this.
Okay, that's the graph.
Okay. Okay, sir.
All right.
Oh,
so now, yes, it's important to label the graphs then. Okay. So now when you pardon?
What are we labeling on the other side? So if this
That's
one
what
is
I'm
for-
saying. If you just put it like this, it's fine for both. That's one graph. That's one graph. Remember, we were saying that Y is equal to a constant over X squared. That if you put it on this side or whether you put it on this
Because
side,
that
it still
equation
applies.
represents both the lines.
Both lines, which is just one graph. So it doesn't matter whether we put that, even if you put an arrow like this, or maybe you put an arrow here and an arrow here, and you say that this is the graph as your 3 over X squared. Doesn't matter.
You try to put it next to the graph because within the graph you can come and draw a line.
Okay, so Miss is saying that you can just come and put here next to the graph Y is equal to 3x squared. So it's a little bit, but you are not supposed to write in space. So I don't know where. Yeah, maybe you can label once you are done drawing all the graphs, so that you have the space. Or I don't know.
Sir.
Yeah.
This graph, do you plot it with your ruler or freehand?
Freehand, please. So
Okay,
every
thank you,
point
sir.
has to be clear. So if you have a flexi curve, then it's easier to draw the flexi curve. Okay. So now that you have done this part, this is now the interesting part of the questions. Now, guys, listen. What I'm going to do here is to explain from the other side. So please follow very well here. Nah? Okay. So now we have the following. So let's say, for example, you drew the graph. Nah? So let's say this was your y-axis and this was your x-axis. Now, this is where it's important for you to understand how the general shapes looks like. So let's say you had this curve over here, and then you had the curve on this side that looks something like this. Are you following? Okay.
Yes,
so
sir.
this is now the graph, which you now can label as y is equal to 3x squared. Okay. Now they are saying on this side, guys, now look very, very carefully. Every time you plot a graph, it's always y is equal to something, right? All right. So now, if you have this value on this side, that means your y is equal to 8. Always like that, right? So if y is equal to 8, that means that the y-axis is cut at 8. That's what it means. Are you following? So what you need to do now is on the y-axis. So if this is your y-axis, you now need to say if this is 8, for example. Guys, let's listen, please, everybody. Hello, guys.
There's somebody watching TV.
Yeah, please switch off the TV, okay? So if you see that this is where the y-axis is cut at 8, you come and you draw a line there, okay? So what does it mean? If we draw the line over there, it means that this now, when you label it, you'll say that this label now is that y is equal to 8 because the y-axis is cut at 8. That's why we have that over here. So it means that this graph of yours is equal to 8. So it cuts the graph here. The green line cuts the graph. Those are the two x's that you must get. So you take your ruler, you see now the line that goes from that intersection straight to the x-axis. And again, from here straight to the x-axis. So this will say be your x1, this will be your x2. Those are the two x values that you put there from the graph.
Won't the x values usually be the same integer with a negative and a positive sign?
Perfect. Sometimes it's like that, sometimes it's not like that. It's only like that if it happens that this value, I mean, your 0 is the center line.
That 0 is
sense?
the center.
Yes, if the 0 is the center, but it's not always the case.
Yeah, and also very important, get your answer from your curve. Because there's a range of answers also that they look at. So you might get that on the other side, maybe you have a 2.1, and the other side you have a 2.2. But for a curve like this, because the values are more or less the same on both sides.
Actually, it's a symmetrical one with the y-axis. So in this case, they will most probably be the same. Your correct answer here will actually be plus 1.7 and I think, let's say, for example, if it's plus 1.7, it's another one is negative 1.7. Does that make sense? All right. Okay, but what I want to do, Pauline, you asked me this question earlier today, so I hope this makes sense, né? So it cuts the y-axis at 8. That's what you have. Are we following? Now, look at the following. The same graph now equals to that. Now, this is not a constant. What is this? This is the shape of a straight line where it is your mx plus your c. So which means you now need to draw that straight line. Does it make sense? Unless they've already asked you previously, which I did not see. They didn't ask you. So which means you can now draw the straight line to get the graph. But this then it's easier to get the straight line from this graph. I mean, let's say, for example, your y is equal to 2x plus 6. That's now if you want to draw that straight line. The other one also is, remember, on the other side, y is also equal to 3x squared. Are you following? So basically the y is equal to the y. That's what they have done here. So where they intersect. Miss wants to add something?
Yeah. So when they give you this question, for the straight line, it's either you use the x and y intercept method. Like for a question where you have 2x plus 6, you can use the x and the y intercept method, or you create a table of values yourself. So one can quickly create a table of values where you just put 3 points. I can have my x and my y, -2, 0, and then I have 1. Okay, so if I substitute -2 there, 2 times -2 gives me -4. 6 minus 4 will give me 2. Okay, and then 2 times 0 is 2.
0.
Plus, I mean, it's 0. 0 plus 6 is 6. But now if I study my graph, 6 is not really on the x. Yeah, no, it's on the y-axis, so it's fine. 2 times 1 is 2 plus 6 is 8. So you're going to use these 3 points to plot the straight line. Otherwise, you also let y be 0, then you can find x. So if my y is 0, I'll have 0 is equal to 2x plus 6. Then I bring 6 to this side, it becomes -6 is equal to 2x. I divide both sides by 2. So then I will have that when my y is 0, my x is -3. So that's 1 point. And then another point, I let x be 0. So then I'll have y is equal to 2 times 0 plus 6. So this will be 0. Then when my x is 0, my y is 6. So having these 2 points, I can plot a straight line. Because to plot a straight line, I just need 2 points. Otherwise, you use the table of values. So the choice is yours.
Sure. I think the table value is easier because the other one includes a lot of algebra.
I like using the other one.
Yes, the choice is yours. Okay, so once you have 2 points, let's say this is gonna be maybe a graph like this. Nah? Let's say you do plot the 2 points and then you get something like this. Let's say the graph goes something like most probably, I don't know, it will cut this at 6. So let's say maybe at 6 here, and then it does something like, I'm not sure, but if we draw the graph, maybe something like that. Again, where it cuts that will give you your 2 values for x, where the straight line cuts that. Does that make sense?
So another thing that you must also take note of is when they say use this graph to answer these questions, the moment you see an equation equal to, it means where are these 2 points intersecting? So when they say 3 over x squared is equal to 8, it means the line y is equal to 8 and the line y is equal to 3 over x squared. Where are these 2 lines? I mean, this graph and this line meeting. So that's what they're basically asking you. If they say it's equal to 0, then you draw your line at 0. Equals to 5, you draw your line at 5.
Thank you, ma'am.
Okay. So from that point, let's go to D. D asks us to find the tangent, okay, of the curve. So let's say here, again, we've got the graph. So let's say we've got the X and the Y like this. And then you have the graph. Let's say this is this side of the graph. And then this is this side of the graph, okay? So now what they're saying is the gradient that you want to find to the curve where X is equal to 1.5. So on the X-axis at 1.5, you're going to draw a line here, a point there, and then you're going to take your ruler and then you're going to draw a tangent. Now, tangent only touches the graph, nah? So it only touches, okay? Let's use a different, at that point, okay? It only touches at that point. Now, they want you to find the gradient. So once you have that black line, what you need to do now is on the line, find 2 points, this point and maybe this point. It's easier to take points that are on the axis. And then what are you going to do? You're going to get your change in your Y, which is your change in Y, and your change in your X. And then you're going to say change in Y over change in X will now be Y2 minus Y1 over your X2 minus X2 minus your X1. That will give you your gradient at that specific point. So the point just needs, the line just needs to touch that point, and you need to draw a line. The longer it is where you can get nice visible points to get your change in Y and change in X, that is going to solve. And then you'll say that will now be your
gradient. Check. On from our previous graph, Mos. Okay.
Yes. I'm not going to that part, okay? Okay. Yeah, Jumbos, that linear programming and simultaneous equations, you are not coming to class, Jumbos.
Sure.
And the same applies for Antonio also. There was a time we just spent almost the whole time just to do linear programming, but guys are not coming to class. Yes, Bibi?
So should we label our tangent line?
No need to label it. You just need it for your what is this, for your gradient.
And your tangent line also, draw it as long as possible so you have
good points.
Yeah.
You can get points, get solid points. Don't get those decimals, because you see what? If you take the point here where it cuts the X-axis and the Y-axis, then you know it will be 0 and something. And on the other side, it will be something and 0. So those are definite points. Are we following? Brandon, you've got a question.
Yes, sir. Sorry, sir. Could you please re-explain this part? I'm struggling with it a bit.
The tangent line.
Yes, sir.
Okay. So you see what, Brandon? The thing is this.
Yeah.
Sir, your voice is absent.
Yeah, it says freezing now.
To have, like, so.
So we can't hear you, sir.
Yo, I thought I was the one tripping you.
You can't see any movement. Oh, Fidel, bro. Oh.
But I thought I was going mid, bro. They can't just froze it.
Oh, man, Fidel.
What's
up?
I'll slap, man.
What's it, Fidel?
Pila grande.
Okay, all right, guys. Hey, everyone, listen. I don't know what happened there, please. Okay.
Sir, my screen.
Are you seeing my screen now?
Yes, sir.
Yeah, but it's man.
Okay, are you seeing the screen?
Yes, sir.
My screen is too small,
Okay,
sir. Can we?
Yes, listen, guys. Okay, listen quickly. So now, for example, for example, if it says, Brendan, listen, draw
Yes,
the
sir.
tangent, where x is equal to say -1, -1. Okay, all right.
Space again, quiet.
Space, freezing, space. Dinner time.
Okay, guys, listen. Now, Brendan, listen. It says y is equal to -1, right? So it
Yes, sir.
means x is equal to -1. So let's say -1 was here. Yeah, this was -1. So what you need to do is it must touch at that point. That's what you're looking at. So what you do now is to bring a ruler, and then you only draw. Let's say, for example, just the tangent, so it just touches the point. Now, like Miss said, you draw as long as possible. Now, Brendan, I'm just trying to explain the concept to you so that you just understand the concept. So the first step is take wherever you are given that x and put the point down for the x, because it's only strictly for the x, right? They can even maybe give
Yes,
you a
sir.
point in terms of a coordinate like that, if it's on the curve. But anyhow, then you need to find the gradient of this line. So how do you find the gradient? You find two nice points. I like to take points that are on the axis, because this point will have a negative value for x, and then y will be 0. This point will have a negative value. I mean, the y will be 0. I mean, x will be 0.
X
and
will
the
be
y
0.
will be a negative value. So once you have those 2 points, you can now assign whatever it is as x1 and y1 and x2 and y2, and change in y over change in x, like your change in y, change in x, and then you get the gradient from there. Does the
Okay, thank you,
concept
sir.
make sense?
Yes, sir.
Okay. Another one, Miss is having another example from another curve. I don't know whether it's the curve we had now. Let me just go back to that. You have on this curve. So you see now what I'm saying here is, look here. So Brendan, coming back to this question, there's some noise, guys.
Topic, guys.
Okay, something super crunchy and what. Just tell that person is not coming into class. So whoever you know, whatever the person's name is or whatever. So please, I want you to just use your, your real names. Otherwise, I'm not going to get you in class. Okay. So Brendan, coming back to this question, draw a suitable curve and find the gradient of m, which is for that curve. Okay. When x is that. Are you following? Now, when we go back to this, x is negative, I mean, 1.5. So what you're going to do on the curve here is you're going to come to 1.5. You know, the x is 1.5. But you're not stopping here. You draw a straight line. Let me use a different color. You draw a straight line until you touch the curve. That's the point where you want, right? You take a ruler and you draw a suitable. This is not a suitable, let me say, this is not a suitable tangent because it doesn't define a tangent. Tangent doesn't cut at more than one position. So it must be that you adjust your ruler to such a point that you only touch it at that point, nowhere else. Like you see, my tangent here has a problem because it touched there. So now I need to draw it perfectly, right? So I must just touch on that point. And I can't draw a teeny whiny small one like that. I try to cover it completely so that I've got a wide range that I'm working with. Does that make sense? Okay.
Yes,
like
sir.
I always say, I like this point, but if it's not, maybe this is a solid point here, which could be a -2 and a 0.5. This could be a point because you already have the x and this is 1. So in this case, you'll take these 2 points, right? So this coordinate here for this one can now be your x is 0.5 and your y is going to be 2. This coordinate, your x is 1.5 and your y will be 0. So now you can assign your x1, y1, and your x2 and y2. Then you say change in y over change in x will then give you the gradient of that green one. Brendan, I hope it's clear. Okay, guys, can you still hear me?
Yes, sir.
Yes, sir. Thank you. Yes, sir. Thank you, sir.
Okay.
Yes, sir.
Great stuff.
Yes, sir.
Okay, so now that is now the first type of graph. Né? The next type again, just look at the graph.
So before we move on.
Yes.
I wanted to ask, sir, do they, in the exam, do they put the range since we are supposed to, since this is supposed to be a range?
No, for the straight line, the range doesn't matter. But the range that they put in the exam is what I told you here, through the inequalities that they give you, especially when you are plotting on the x-axis, on the y-axis. How far you can go in terms of where is your x going and where is, that's the only range I can think of. Besides that, when you are drawing to a curve, let's say this was what you are having, right? So you had this and you had that. So you draw the straight line here, the curve, I mean the tangent. So in the tangent, you don't just draw like this. You know, the thing about the tangent is anywhere on that line, the gradient will be the same. It doesn't matter how long that line is. The reason why we want you to draw as long as possible is so that you find nice, suitable points. That's the reason. But what do you mean by the range?
So when you draw the tangent, some people get different answers, and then
that means that this means the range that they are marking with can be, let's say if your original answer is supposed to be 1.7, because we are all humans, right? Nobody will draw it perfectly. Then they can say there's an error range of 0.5 plus minus. So if somebody says maybe 1.65 can be an answer, right? That is now less 0.5, and then the actual answer is here, or it could also be 1.75. So the range can be from 1.6, maybe up to 1.75, maybe 1.65. Yes, so there is a range. You'll even see when we share the marking schemes. Now, after the lesson, we'll share the marking schemes. Okay.
But you must be within the range.
You must be within the range. So guys, let's look at the next one. Again, the key point is, what is the general curve going to look like? Since it is negative, what's going to happen here is that this will be to this direction, and then this will be to this direction. Does that make sense? So after you've just put your S and your T by plugging in the respective X, you'll get those values. You go and plot, you get your values there, you go and plot, and then this one was done properly. Nah? What I mean with properly here is, you see, what they want to do, actually the other one was also fine, it was my mistake. The reason why they gave you the X and not the Y is because this graph, they talk about the range in the X here and the range again on this side, okay? So this one will range from the -3 up to 0.5. So for example, this curve that I draw on this side, yeah, will be only from here, -3, and then it will only go up to 0.5, -0.5. The curve I draw here will only be from the 0.5 up to 3 only. That's what it means.
Sorry,
Are we following?
sorry, sir. My screen isn't showing anything, sir.
Okay, now that is on your side, Danny boy.
Okay, so I'll just leave and come back again then, sir.
Yeah,
I
then
don't
we
know.
just accept you again. Okay, so now they say, this is what Miss was saying. It is now important to label the curve. So when you label the curve, you will now say it was now 3 over x or negative, right? That's what I think. And then on the same grid, draw the following line. Now, guys, this line is very, very important. Eh? Okay, this line, I want you to understand. Another general line that we have is if you have your x and your y axis like this. Nah? If you go back to the table method and you say on the table method, what Miss was explaining earlier with the x and the y is you want to look into from 0 to the negative side and then to the positive side. So you select values, maybe -1, -2, here +1, +2. So you want to see how the graph will react on the positive side and the negative side. So if you take the graph of y is equal to x, if I substitute x as -2, I put -2 here, then the y will also be -2, isn't it? If I put -1, then the y will also be -1. If I put 0, because it's y is equal to x, right? It will be 0. But if I put 1, it will also be 1. If I put 2, it will also be 2. So if you go and plot here, let's try another color, -2 and -2. Let's say, for example, -2 and -2. So they meet here. So this is -2, -2, -1, -1, 0, 0, 1, 1, and then we put it according to this, right? Then my graph would look like that. So if the graph is y is equal to x, as proven by the table method, it will go through the origin going to the positive gradient. Are we following? The moment I add a 2 here, or y is equal to maybe a half, then it will just be either more gradual or more steep, but it will still go through the origin. Does that make sense? Now, if we have y is equal to -x, and I do the table method, okay? So I say x, y, and I do the same thing, put the 0, -1, -2, 1, and 2. If you plot it again, remember, whatever I put there, I must multiply by negative, right? So that graph would look something like this, also through the origin, but just with a negative gradient. Does that make sense, guys? And it will always go through 1. So it will always be here, 1 and -1, and then it will go to 2 and -2, and it will go to 3 and -3. Here, if it's positive, it will be 1 and 1, -1 and -1, -2 and -2, 2 and 2. That's what's going to happen. So that's how you can draw that graph. Why am I explaining that graph over here? Because they ask us on the same grid. You need to know the basics, guys. On the same grid, they said we must draw the graph of y is equal to -x. So for example, you know, on this grid, let me just go back to this. Maybe it will help a little bit. Nah? Where is my grid? Okay, let's say on this grid, if I plot it now, for some reason, I get the following. So let's say I plot it nicely and I get that, and I plot it nicely and I get that. All right, now they say I plot my y is equal to -x. So it has to pass through the origin. And then what I'm saying, if it's 1, it's -1 here, right? And if it's 2, it is -2. So that's the next point. If it's 3 and -3, the same applies on this side, 1 and -1, 2 and -2, 3. So now this is what my graph would look like. So I'm in my line, my graph, yes. So now I have that. That's my graph over there. And this one will now be y is equal to 3 over x with a negative. So now they would say, the next follow-up question would be, after you have drawn them, find the values where they intersect. But they ask it like this. They will ask it like this, saying, what happens if that 3 over x negative is equal to negative, say, x, for example, right? So now you see this whole thing was y. This whole thing was y. So it means those points where they intersect, you must come and get your x value and your y value. You can put it as a coordinate, your x value and your y value. You put your x and your y as a coordinate. This point, you put your x and your y as a coordinate. Does it make sense? Okay,
yes,
so let's
sir.
go back.
I just
Okay, sorry, Miss wants to add
Sorry.
something.
Yeah, I just wanted to add something. Sometimes also they can give you this curve. They sometimes also give you this curve as a f of x function. Yeah, they give you this curve as a f of x function, and then they can give you this curve as a g of x. And then instead of them writing them like this, they will ask, find f of x is equal to g of x. Then you automatically know they want to find where are these two graphs meeting. Do you understand?
Yes.
Yes, ma'am.
Okay, guys. So now from that point, the next thing is, okay, so we understand. Yeah, you see how they put it, how they put the question. If that is equal to that. Now remember, this whole thing here was equal to y. This whole thing was equal to y. So basically, you'll just put the 2x value. So you'll say this or x is equal to that. That's why we'll have 2 marks from the graph, because they say use the graph to solve that equation.
Sir?
Yes.
I'm sorry, but my parents say that we need to go now.
Okay, no problem. Okay, now Brendan, just the last one here. Draw the tangent here at this point. So remember, Brendan, here you are having the curve looking like this and like that. Are you following? So now the tangent that you need to draw is at.
Yes, Jamie.
Okay, sorry guys. Yes, Jamie. I think she said they need to go.
Yes, we need to go now. I'm sorry.
Okay, no problem, Jamie. Okay, now this one, where you say x is equal to 1. I always say, which axis is cut? The x-axis, right? Where is it cut? At 1. So the x-axis is cut at 1. That means at the value of 1, you're going to come and draw a straight line like that.
Sorry, sir, to bother. Me and Jamie unfortunately need to go. And our Wi-Fi cut out, so her laptop like shut out. So I'm just letting you guys know. But thank you. This was extremely helpful, especially on a lot of the questions that we had. And thank you very, very much for sir and ma'am's help with this. We really appreciate all the effort.
Okay, all right. I'm sure you'll do very well tomorrow.
Thank you, sir.
Okay, bye. So guys, getting back to this, look here. This axis, because it's just saying, just get the tangent. You're only going to put the point down there. You're going to take your ruler, and then you're going to draw that it only touches the point over there, right? And then what are we going to do after that? We're going to get the change in y over the change in x. Né? So change in y, and then the change in your x. That will now give you your gradient. Guys, do you see the repetition here?
And if you observe also, this question is slightly different from the other one, because the other question, they first ask you to draw, and within the same question, they asked you to estimate the gradient, but this one was a follow through. Do you guys see that?
Yes, miss.
Okay, guys. So the others, we're not going to completely do that, but the fact that we have different graphs, that's what we want to look at now. So this one here, like Miss was saying, you see how they gave it to you. Y is equal to g of x. Because it's a straight line, it will have a general form of mx plus c, right? Okay, so now from this one, they will then go further, and then they say that equation that you had on the other side, y is equal to g of x, né? Find the gradient. So from that line that's given, you take 2 points, change in y, change in x, then you get your gradient. Here, what you need to do is the values you have here, you plug them in wherever you see x, then you get the respective y output. Okay, same thing. So you put in 2, for example, 2 squared minus 2, and then the x is 2 plus, minus 3. This will give you 4. This is going to give you another 4. And then this is going to give you just the negative 3. So this will cancel out. This will be equal to negative 3. Yeah? If you are doing this one, to get this answer, you'll now put 4 in the place of 2. So this is going to give you 16. And this will also be another 16. This will be 8, And then this will now be negative 3. So this will be 8 minus 3. That will give you 5. So those are the pairs, coordinate pairs that you have to go and plot on your graph. And since it is an x squared and it is positive, your graph would look something like that. Now remember, you already had a line that was already given to you. So let's say you go and draw your curve like this. All right. Then they will now say, for example, find the coordinates of the turning point of that curve using the graph. So the turning point of y is equal to fx. Remember, the other one was y is equal to g of x. That was the straight line. Now, the one that you are drawing from this table here will be y is equal to f of x. So they are saying finding the turning point of this line. So you just go to the graph and you can get it from the graph, because on the same grid, you can just get the coordinates there of the turning point, your x value and your y value.
Sorry, Sir, to all the questions that we had, and thank you very, very much for Sir and
Yo, something is wrong here. Okay, guys, do you still hear me?
Yes, sir.
Sir, man, I was confusing because I clicked on YouTube now, sir.
Yeah, that's your problem. Now the YouTube is repeating on this side, Danny. So let's focus on the class, Danny. Now let's quickly look at this. This says f of x is equal to 0. So what does it mean? It means that whole thing that you had, f of x, remember, was your x squared minus your 2x minus your 3 now equals to 0. So you solve that quadratic equation. Now they say once you have plot that, remember, you plot the graph, right? So they are saying when f of x is equal to 0. So it's like saying that your y is equal to 0. So basically that will be at the x-axis. Are we following? So you will get these values, those two x values that you have over here. Technically, you are saying that if you have, for example, y is equal to 2x minus x minus 3, that's what you plot. Now you are basically making your y 0. So it's like y is equal to 0. You're plotting that line, which is the x-axis. Does that make sense, guys? So you are basically telling us, or they are telling you to do the following. This axis here. So where it cuts the graph, those are the two x values you'll put here and there. And then finally, what Miss was showing you to say that this f of x is equal to that. That means where the straight line is cutting the curve, because this guy was your f of x and the straight line was your g of x. So in other words, you are taking whatever that straight line was and you are equating that, the straight line x to the x squared basically. And then you can solve your x values only because they want you to list the x here and your x. They don't want you to put the
So you must also remember here, whatever you are doing is coming from the graph. So you are not going to use a quadratic formula. You are not going to. This can be done algebraically or graphically. So with this part of your paper, they want you to use the graph. Are we together?
Yes, ma'am.
Okay.
I think the last one, just to demonstrate or show, is the exponential graph. So when you have a constant raised to a variable, okay, again, what will you do to get your y's? You'll just put 2 and then you'll put your -2 up there. Maybe we'll use a different color, -2. Are you following? So it will be 0.25. Basically from indices, this is the same as 1 over 2 to the power of 2, which is going to be 1 over 4. Does that make sense? Which is 0.25. So then again, for this one, you'll now put -1 instead of the -2. And then if you put -2, this will be 0.5. Are you following? And for this one, you'd put now 2 raised to the power of 8. 2 raised to the power of 3 will just be 8. So again, use the coordinate pairs to come and draw the graph. So your graph would look something like this. From -2 and 0.25, maybe somewhere here. And that's the exponential graph that will go up like that.
Wait, sir?
Yes.
Sir? Sorry, so can you re-explain that? How do you get the 0.25 from -2?
Go and plug it in your calculator to say 2 to the power of x, right? So now you will say 2 to the power of -2. Just go and plug it in like that in your calculator. It will give you 1 over 4, which is 0.25. Just like the other one we were doing, yeah? You see, this is your equation. Look at this. This is your equation. So wherever there is x, you come and replace it with the x value. This, you go and plug it into your calculator. Just like the other question you asked there, Brandon. You just go and plug it into your calculator. And then this will eventually give you the pairs. Né? It will give you the points like this. So you'll just connect the points. So what I'm saying is, if you have a constant raised to a variable, it will always form that. Does that make sense? If it's negative, then it will be to that direction.
Yes, thank you, sir.
Okay, perfect. So that was the last part. But anyway, the same thing applies. So once you have plot this graph and it looks something like this, so this graph looks something like this, then they say at the point, draw a tangent at the point where x is equal to 1. So what do you do on your x-axis? You go and say where x is equal to 1. So you go up straight. At that point, you draw a tangent, take your ruler. So you put it nicely together. And then you put it like this. And then you draw a tangent that only touches that point. And then once you have drawn the tangent, they want you to do what with the tangent? They want you to find the gradient.
Well,
so again, 2 points, change in y, change in x, change in y. Guys, do you see every time they ask for the gradient? Every time they equate it to something. So you'll then put the gradient that you find there at that point. So again, if it was just to demonstrate something, if it was maybe the point where x is equal to -1, do you see the gradient here? So maybe you draw like that. That gradient will be different from this gradient here. And then on the same grid, draw this graph. This is a straight line, but negative, right? You can do it by the, what do you call this? By the table or by the other method. And then this gradient, I mean, this graph might look something like this. So where it cuts the exponential graph is where they say, where this graph is equal to that, find the x. So where it cuts, you just come and get only the x value. They don't ask for the coordinate. Graphically, you have to form that. So they don't ask for the coordinate. They just want the x value, okay? Okay. Okay. Okay, hold on.
If you observe all of the questions, most of the questions that we did were x to the power of 2. Our highest degree is a 2. So because it's a 2, you will have 2 x values when you draw a straight line. So you will have 2 x values and it's 2 marks. But for this one, because it's a curve that's just one-sided, so that means you are only going to get 1 point of x.
Okay, guys, just hold on a little bit. Okay, so anyway, then you will get this part where it now intersects where you can get your x value. Okay, guys, I think the graphs are done.
The last question is
yeah.
But I don't know.
Sir?
Yes.
So,
okay, guys.
Here's the thing that I have to go now.
Oh, okay.
Thank you,
guys, listen.
Welcome.
Okay, guys, listen. I don't want to go beyond 9 o'clock, honestly speaking. Nah? That's why I did not want to solve these graphs like this. I wanted to give you an idea around it and go to that. But anyway, an asymptote, if you get a question like this for tomorrow, let's say you've got your x value and you've got your y value. An asymptote means that it just gets as close as possible to the x or the y, but it never cuts or touches it, right? Now explain why the x value of this curve. Okay, the asymptote is, the x-axis is the asymptote to the curve. Now, if you look at this curve that we're talking about, like 2 is equal to the power of x. What it means here is this graph here, if it cuts the x-axis, that means it will have a value. Does that make sense? All right. So if it touches the x-axis at that value, this will just become a constant. Are you following? So it must just come as close as possible, but not touch that. Okay. That's what an asymptote means. So guys, we have about 20 minutes just to go through that part on the second, I think it was algebra. Statistics. Statistics are there so, under algebra. 20 minutes to do that. Can you do what?
Excuse me?
Can Sir please explain that again, the asymptote? What?
as it, what you'll say, what your answer will be is you will say it's the line, the curve is getting as close as possible to the x-axis, but it's not touching. So an asymptote is where your curve gets as close as possible to that thing, but it does not touch that thing. So our x-axis is the asymptote because the curve is getting as close as possible to the x-axis. When you draw it, that's how it will look like. It will get as close as possible to the x-axis, but it does not touch the x-axis.
Okay, thank you, ma'am.
Yeah, so that's how you are going to explain that. Okay, we are quickly going to look at statistics, because that one also covers a lot of marks in the exam.
But after
You know what I want to suggest? Let's just share this
after statistics, can we do algebra?
We are going to share the solutions because you have to also go through these things by yourself.
Listen, guys, due to time, I'm gonna share and I'm just gonna explain on the group as well. So I don't want you to sleep late. So at least you can have an hour to yourself. Guys, I don't want you to sleep beyond 10 o'clock because if you sleep from 10 to 6 o'clock, that's a good 8 hours and you need 8 hours, right? All right, so what I'm going to do now is I'm just gonna share some of the questions, almost 90% of the questions with the solutions. Now, guys, this thing here, it is in the sense of the whole question paper with the solutions. Are you following? So what it means is you need to identify the questions that you want the solutions to, and then scroll and go to the marking scheme that will be immediately after that paper. Are you following? So I'm going to show you an example. Just give me some time. Let me just get back to this. Okay, so listen, guys, we are basically taking paper 2 and paper 4. Those are the main papers that we're looking at. So I'll stop sharing that screen. Just give me a second.
Paper 4.
Okay. Okay, just a second. Okay, guys, are you still there?
Yes, sir. Yes, sir.
Okay, guys. So let's do it like this. Okay, so now you see the screen, right? So what it means here is that, let's say, for example, this is paper from, say, 2016, for example. So you go through the paper, and then at the end of the paper, like, for example, this question you've seen in your papers, then the solutions are there for that respective paper. So you look at the numbers. Once you're done with that one, then you go to 2017, paper 2. So you see, for example, this question is there, question 6. Can you see that? So you go now to the marking scheme at the end of that to question 6. So you go and check at the question 6, and then the same applies for all the other papers. All the questions, about 90% of these questions will be there. So I hope that is clear. Do you understand what I'm saying?
Yes,
sir.
Okay.
Yes, sir.
So we'll call it because I really did not want to go beyond this. And I know graphs take some time, guys. So I think the main thing was just the tangent line and when the two graphs are equated. And that's honestly what I wanted to just discuss. 10 minutes and then we go. But for now, go through the questions yourself because you'll just get tired. And then tomorrow, please do not sleep later than 10 o'clock, guys. Please, please. Okay.
Yeah, and another thing that I want to advise you, tomorrow when you write your exam, start with questions that you understand first, and then you go to the questions that you don't understand at all. And then after your first exam, when you are done writing that exam, please study the question paper to see which questions they did not ask at all. So that time that you have between the morning session and the afternoon session, revise those topics that were not asked in the question paper at all as well. Because what they try to do is, if they ask linear programming in paper 1, and then maybe paper 2, they'll ask graphs of functions. So you must also look at the questions that are asked in the paper, or questions that are not asked at all. And then you revise on that. But please don't have this tendency of you finish writing in the morning and then you just wait for the afternoon without you revising before you write in the afternoon.
Yes, miss.
Yes, ma'am.
Yes, miss.
Okay, guys.
Yes.
All the best. All the best. And we pray for you. And please don't sleep late. Please. Not later than 10 o'clock. If you want to still go, not later than 12, please. Nah? So that you are rested.
Okay.
Those things
Not later
you
than
have done,
12.
you will remember them, especially if you have worked through the papers. Okay. Have a blessed day.